Good morning, everyone. Welcome back. Okay, welcome back to today's session. We are continuing with what we were doing yesterday, and what we did yesterday basically we analyzed. In fact, yesterday we said we wanted to bring out an application that does to its neutral axis, and we'll be dealing with three types of loads which we added later on, four types: point loads, uniformly distributed load, trapezoidal load, and triangularly distributed loads, right? And we said the beam is laterally constrained, and we will be using BS5950. That's what we'll be using. And we are dealing with universal beam sections only, right? So within that scope, we said the steps that we'll be taking. We'll have to model the beam in our application. We'll have to calculate internal forces to determine the maximum internal moment, maximum shear force, and then go to the design according to BS 5950, and then design the beam accordingly. So yesterday we focused on determining the general equations for the general equations for internal forces, okay, so that we can compound them no matter how the user models his forces. So we did that, and then we created functions yesterday. We created two functions. Right here we have the internal point and the internal trapeze. We created those two functions yesterday. Okay, they are here even. Internal point and internal trapeze. We created two functions yesterday, which enable us to get uh, the equations, the distribution equations of all of the internal forces we need. In this case, just shear and bending moment. Distribution equations for each zone for hmm, all of the internal constraints. So we had that, but then yesterday in testing these equations, we saw that it may have some limits, okay? Because by default, when we are doing it, like this trapezoidal one, for example, where we are here in MATLAB, okay, which we did yesterday, it has by default three zones, okay? But we may have different modeling. We may have different modelings for this. And so we must cater for the fact that for those different modelings, we may have different modelings that have a different number of zones. So for example, what we model was something like this. I hope that the small screen there is visible. What we modeled is something like this. We have A here, we have B here, and we have C this way, okay? And then the overall length here is L, right? So here we have cure 1, and here we have our cure 2. That's what we modeled that yesterday. And then according to our equation, which is here, okay, we have our m of x for zone 1 this way, which is expressed as polynomials, as we saw yesterday. We have our 2 our m2 of x rather for zone 2, our m3 of x, all expressed as polynomial, and then our t1 of x, our t2 of x, and our t3 of x, right? We saw all of that yesterday, but then we wanted to implement this and try it on the case of a uniformly distributed beam, okay, like this. And then we saw that there will be a problem, right? There will be a problem here. Why? Because this model here has just one zone. It doesn't have three zones like what we have here. This zone, and that zone. And the one zone here corresponds to the zone where the load is distributed, which is this one here. So it means that we need to transform our function to suit the different kinds of zones that we have. And we can know how many zones we are having, okay, depending on the values of A and B. For example, in this case, the value of A is equals to 0, right? And the value of B is equals to L. When the value of A is equals to 0 and the value of B is equals to L, then we have just one zone, and that one zone will be what? Will be the second zone. So that's what we are interested in. So we can already start transforming our function to suit so that we don't stress, right? We don't stress in any regards in future. Okay, so let's just do that. Here we have all the values. Maybe I should write it down and then we'll be able to change it later on. So we are saying that if, right? We are saying that if A is equal to 0, right? Right here, if this A is equal to 0, it does not exist here because the only distance we have here is B, where the load is distributed. Okay, if A is equals to 0 and wow, oh my god, my and is not working. So let me open the virtual keyboard. Come on, come on, come on, come on. Okay, just a minute, please. Good morning, guys, and welcome, welcome. I did not read your good morning. You guys came a little bit late. Okay, so I can now type it. So we say and B is equal to L, right? If we have this and B equal L, then we have only one zone. Okay, we have only one zone in both cases, and that zone is the middle zone, which corresponds to zone 2 here. Okay, so in that case we'll have mx for the sake of consistency, right? We'll keep all of our things in cells for the sake of consistency. We have mx to be just one zone, which is that one. Okay, and we have tx to be just one zone, which is still the middle one, right? Which is this one, zone 2. Okay, so what other exceptional case do we have? If I have a case where the load is instead like this, right? Then here again, I'm in a case where A is equals to 0, right? But B is what? B is less than L. Okay, remember I'm saying A and B here because when we're modeling here, we used A and B. So those are the only values that we have access to. And it is from these values that we should be able to, you understand, we should be able to determine what happens. So again, we are in the case of if A is equals to 0. So you see that in these two cases, A is equals to 0, right? So it means that here, I can even put an if inside this if, okay? So a way of saying if A is equals to 0, in the midst of A being equals to 0, right? If B is equal to L, then do this. Else, so else, let me just say else if, okay? Else if B is less than L, right? Because here we have B, but it is not, okay, it is less than L, it is smaller than L. So we'll say if B is less than L, then in this case, what do we have? Let me put end here. This end corresponds to the second if, and then I will put another end down, which corresponds to this other if here. Okay, let me indent all of this to know that we are in a function. Okay, and just for the sake of cleanliness, let me put end for that function. All right, so I am here. Here it needs to be indented, right, to show that we are inside the if. Let me go back again with this and enter so that it's indented too. Perfect. So we have to write clean code. Good. So in this case now, how many zones do we have? We have two zones. We have this one and this one, which corresponds to the second and the third zone of our original diagram, right? So very simple. We apply it the way we see it. Okay, the second, and the third zone. So we have mx. We have mx will be equal to something, and we have tx will be equal to something, right? So for mx, we are saying the second and the third zone. This is it. For tx, we are saying the second and the third zone. This is it. All right. So, what other case do we have? So this is the cases where a is equal to 0, right? But now, if a is different from 0, if a is different from 0, so else if, let's say a is greater than 0, right? Greater than 0, strictly greater than 0, and less than L, right? It has to be less than L. So, oh my god. Okay. I'm trying to get my on-screen keyboard. And A less than L. All right. So, an A less than L, in that case, if, what do we have now? So, the last case is this one. The last exceptional case is this one, where we have something like this. All right. This is the last exceptional case. So we have a value for A which is greater than 0. Then we have a value for B, but there is no C. All right. And then the overall distance here is L. In this case, we'll still have two zones, 1, 2, not three zones, right? So what do we do in that case? We are in a case where, if you notice, A plus B is equals to L, right? You need to learn how to use what you have to get what you want. Okay, so in this case we have A plus B equal L, right? So I will say if A plus B, okay, is equal to L, then we are in another scenario. Okay, we'll have else, let me just say else, and so normally it is else if, again, B is less than L. So I'm putting all these conditions because we want to be sure that if the user doesn't respect all of these norms, okay, then we have to emit an error message. Okay, we need to make sure that no matter the load that he's defining, it is within the span. It is within the span of the beam. Okay, so I could say just else here, but else here would imply that B can take any value, but we don't want B to take any value. We need B to be less than, L. Okay, just like here is less than L. Good. So in this case where we have A plus B equal to L, which is our case here, we will have two zones, and the two zones correspond to what? The first here and the second zone. So again, I will have MX is equal to something, and then I will have Tx is equal to something, right? And let's just finish with this one. So this one will be, we are saying the first and the second zone, which is this one, right? The first here, what's that? Okay, yeah, that's correct. The first, and the second, right? And here the first and the second. And then right here is the case where all three zones are found. Okay, is the case where we have these two equations actually. The only case where we have that. All right. So normally we are also supposed to say this for B. Okay, B has to be greater than 0 normally. What is it? Greater than 0 and less than L. All right, it has to be the same thing because we don't want B to be negative, right? A negative number will still be less than L, but it has to be greater than 0. So let's just say the same thing here. Okay, so we have said else if this is that, else if that is that. Now let's just say else, okay, to complete everything. So else we want an error message to be sent. All right, and the error message should say enter correct values for A and B, for example, something like that. Okay, so now let's try to implement and test our function. uh I'll copy this. What's this thing doing there? Okay. Okay, so I'll copy this and then let's try to do what we did again yesterday. Okay, you guys know that for this case, let's try to implement this case. Okay, I'll give here a value of 10 and I'll give the distance here a value of, let's just say 5. Okay, let's just say 5. You know that the maximum moment for this particular beam here occurs in the middle, right? And the value is cure L squared on 8. Okay, that's what the maximum moment for simply supported distributed beam. That's the formula here. Cure here will be 10 and L will be 5. So it means that our M max, which is in the middle, actually what I was saying is ML of 2 will be equal to cure S squared on 8, which will be equal to 10 times 25. 25 here is 5 squared, right? Divided by 8. So what are we getting? 4 year 2, 4 year hey, what am I saying? Here 4, right? And then here 5. 5 times 25, that math is already complex. 125 divided by 4. So our maximum value should give us something like 31.25. Okay? 31.25. So let's try to see whether it's the same thing, is the same thing this way. Let's model this very beam and see whether it's the same thing this way. So to model that beam, what will I have? Oh la la. To model the beam, my cure 1 will be 10. Right? You remember, my cure 1 will be the same as my cure 2. My cure 1 will be 10, my cure 2 will be 10, and then my L will be 5, my A will be 0, and my B will be the same as L, which is 5. All right? So we enter that. Huh? How do we have? Okay, okay, good, good. One by one cell, one by one cell. Perfect. So just one zone. Okay. So it means that let's see what our mx is actually. Mx of 1. Just one zone. So it is, if we have to read this, our mx is something like 5 squared times 25x, right? That's what we have. The polynomial. Okay, you remember. So because it is 4 values, this is a coefficient of x cubed, this is a coefficient of x squared, this is a coefficient of x, and this is a coefficient this is a constant, right? So we'll have negative 5x squared plus 25x. Okay. So now let's do polyval and see at 2.5 whether we will have the value 31.25. That's what we want. Okay. So 2.5 here is the middle. We said the maximum occurs at the middle, right? So if we get the value of this our equation in the middle and it gives us 31.25, then it means that our equation is correct. So we want polyval of mx of 1, which is our equation, at position 2.5. What does that give us? 31.25. Perfect, right? So it means that our equation is correct. So you see that it has generalized. The formula that we entered was a formula for a trapezoidal something. Okay? But even with a uniformly distributed, all we need to represent is cure1 is equals to cure2, and we are back to a normal status quo. And triangularly distributed will work exactly the same. Cure1 will be 0 and cure2 will have a value, or cure2 will be 0 and cure1 will have a value. It will be exactly the same. Okay, so I think we are done with this. Okay, that should work for all cases. The other exceptional one that we want to take now into consideration is the case of the point load. So for the point load, what we model was something like this. Okay, we have A here, and we have B this way, right? And then we have L just like that. Okay, why is my L coming out on this on that line? Okay, so we have L just like that. Okay, and then we have our P here. So in this case, we have two exceptional cases here. Here it will give us two zones all the time, no problem. But there are cases where we may have just one zone. All right, and a case like this one, where the load is applied at the level of the support here. Okay, so in this case, I will not have, I will have A is equal to 0 in this case. So let's go to our point load. Okay, so we are here. So we have just L and A here. Okay, so it's very simple. All we need to say, if A is equal to 0, right? If A is equal to 0, then there is something else. Else if, right? Else if A is equal to L, because that's the other case. The other case is we have something like this, and the load is instead applied here. So I'm trying to identify the cases. This will be A, right? At the same time, this will be L. So A will be equals to L. I'm trying to identify the cases that will give us a different number of zones than the original case that we had. Remember, that's what I'm doing. Okay, because originally we had 3 zones for the trapezoidal, and then here we had 2 zones. But there are cases where the load is applied, we have just 1 zone, not 2 zones. Okay, either the left or the right one. So else if A is equal to L, then we have something else, right? Else, no, else if again, right? Else if I want this particular interpretation. If A, this one, else if A is greater than 0 and A less than L, right? Then okay, so else if A is greater than 0 and A less than L, then I will have something. Then else, then we'll have an error, right? End. So if A is equal to 0 now, what happens? Let me just copy this. Let's send this other way, and then I'll have an end like that. Okay. So if A is equal to 0, then we are in the case of just one zone, right? We are in the case of just one zone, and the zone is the left one. Okay. So I'll have just this second zone to take into consideration. All right. If A is equals to L, again we have just one zone. So, again we have just one zone, and I'll have just this other zone here to take the first zone to take into consideration, right? So this part, where is it? This part can vamoose, right? Now this is the case where we'll have all of the formulae. Okay. This is the case where we'll have all of the formulae. If A is different from 0 and A is different from L, then it means that our point load is applied somewhere in the beam. And wherever it is applied, it will cause a discontinuity that will provoke 2 zones, right? So we have the 2 equations for the 2 zones. And else again, we can enter this our error message. We even have to try that error message here to see if it's if it's actually going through. Okay, so error, enter correct value for A, right? For A. So here I will say enter correct values for A slash or, right? And or B. Good. So let's try that. In all of these cases, actually, we have to make sure also that L is what? That L is greater than 0, right? Because he can enter L here as a negative number also. So let's enter that as a very first condition before it even looks for all the rest. If L is greater than 0, okay? Greater than 0. Yeah, strictly greater than 0. So a way of saying that L has to be positive. Then it should do all of these. And then we can end here. Okay, and if it is not the case, if L is not greater than 0, let me just put the else here. We'll send an error message again. We'll send an error message and say enter correct value for L. Okay, or we say L must be positive. L must be positive. And here, instead of saying a let's say values for A and or B must be comprised between 0 and L. All right. Okay. Even though B must not really be comprised between 0 and L, because B always has to be positive, but it's okay. Let's just leave it like that for now. I'll just copy that. Let me copy all of this down apart, and we'll use it down. Okay. So we'll use it. Where did I copy from? Okay, from here. We'll use it down from here down. All right. Here we need to send it this. No, it's okay there. This one like that. Let's not get confused here. This one here, I'll need to. Is it here? Yes, that's correct. I'll need to send it this way. This one comes a little bit this way, and then the end there is because I did not put if L is greater than 0. Okay, and so I can shift this one this way now. Perfect, we have our green. Okay, we have our green. If L is else error, L must be positive values for A, not A or B. Okay, must be comprised between 0 and L. Good. So I think everything here is okay now for these two functions. Let's try. Let's test some things out. So let me try to enter L as a negative value. Okay, where is L here? I put the same 10 10. Okay, this is L. Let me put negative 5 instead. Okay, so I have an error message. L must be positive, right? That's what we want. So now let's put 5 there, and then put the value of B to something like 6. Okay, what is it saying? Output argument assign output argument mx not assigned during calling. So it's a way of saying that we don't take into consideration the fact that b can exceed the value of, let me look at that, that b can exceed the value of L. Okay, so if if L greater than 0, it will enter here. If this, else, if this, else that. Okay, the problem is that it does enter here because it finds that, so it means I was supposed to do an else again inside here to talk about B, and then this other else here will talk only about A. Okay, this one here will talk only about A, and we can put another error message in between each of them to talk about the error from B. Okay, so here we'll say else if B that, and then basically the same thing for the one on top. The point load will not have the same problem. Okay, yeah, that should do. Let's try that again. Try that again. Good. So values for B must be comprised between, so that's the B that will change here. So let me try to put B to conformity, and then we put A maybe to something like -8. You see, values for A now must be comprised from 0 to L. So it's perfect. Okay, we have our code, we have our code, we have it takes into consideration all the different loadings that we have. So what does this mean? What we have just done, what does this mean? It means that for every modeling that the user will do on our interface, okay, we have the correct equation. We have the correct moment distribution and the correct share distribution for whatsoever modeling that he represents. Okay, it's true that at the end of the day, we need to be able to know how to combine them in such a way that it gives us a correct composite, a correct composite distribution. But that's a problem for a different time, for later. Okay, for later. So good. Our equations are okay. The next thing we'd like to focus on now is actually to work on our interface. That's what we want to do right now. Okay. Uh, we want to work on our interface. So let me feel inspired. So I should say this again. I did not really prepare for this because I want. I need to place myself in the shoes of the students. So I want to just do the project. Okay. Just do it as though I'm the one sitting down and studying and doing it, right? So let's go ahead. So I want to do an interface. The interface is supposed to be for my overall project, right? It's supposed to design my UB section at the end of the day. That's what my interface is supposed to do. So what we want to see, uh, the first thing we want to do is to enable our users to model, right? That's the very first thing. Our users should be able to come and then represent the length of the beam, represent the loads on the beam. Any loads that he wants, he should represent it. And when he represents it, he should see it, that he has represented it correctly or wrongly. At the level of the loads, he should choose whether it should be a dead load or a live load, etc. For now, I think that's the main concern. Okay, so let me feel inspired. The way I'll do the interface will be something like this. So this will be my window, all right? And I'll share it into, let me say, something like that, where we have approximately 0.3 this way of the 0.3 of the overall width this way, and 0.7. So 30% of the overall width this way, and 70% of the overall width this other way. Okay, so if I say this thing should be 1000 of width, right? Then I'll say here is 300, and our measurements here are in pixel. I'll say here will be 300, and here would be 700 pixel, and our height. Just start doing that. I'm just assuming our height. Let's do trial by error here, okay, and see what happens. Now, all of this will be done in what we call a figure window, okay? So if I type figure, in MATLAB, figure is where you draw all your interface. When you want to draw something that, okay, a beginning of a software that will be an interface or something, that's where you start, okay? So this right here is my figure. This window here is the window that I'm trying to draw here, and this is where everything will appear. All right. So what I'm saying, I want to try to give this a width of 1000 and then a height of maybe, let's say, 500, and let's see what it looks like to see whether it is convenient for us. So for that, I'll use the position property of the figure. So I'll say figure, I'll open the bracket and say position. So if right now you're not understanding what is happening here, I have a whole playlist on YouTube. Okay, I have a whole playlist on YouTube, a very old playlist that uh, that even my very first videos that I did on YouTube that can help you. Okay, that will help you understand what all of these things are. I cannot re-explain them here because we have a whole project to finish. If I start explaining these things, I'll be explaining them to some details. But if I start explaining them from scratch, then we'll have a lot of time to waste here. So let me just take some time here and show you. So if you go to YouTube, you just type my name there. Okay, you just type my name there. It should take you to my channel, or it should propose my channel to you, right? So here I am. So if you click there, if you click there, just browse down. This is it right here. Okay, MATLAB programming guide application. So this playlist here, all right, this playlist here is a whole playlist where I've explained a lot of stuff, on these graphical user interfaces and graphics even in it. Okay, so you can look at that and it will help you a lot to understand everything that we are doing now. So that was in passing. So now we'll use the position property. The position property, the first two items that we indicate are, okay, the left. So if we say that this is supposed to be in the computer, the first two items that we indicate is this distance. Where is it located? Where does this point start following the x dimension, and where does it start following the y dimension? In our case, I will not care. I will just put it 0, 0 for now, because what I will need for this figure is for it to be centered, and I know how I will do that. Okay, and we now need the next input there is the width of the figure and then the height of the figure. So it will be 1000 that we want for the width, and then we want to try 500 for the height. So let me try that again, and this is what it gives us. So you see that 0, 0, look at where it came out. It came out at 0, 0 here, right, at the origin, and then the width now is 1000 and the height is 500, and I think this is perfect. Okay, this will do just fine. So we're saying that the height here, let me put it like that, the height here will be 500. All right, so I have that. So I will divide this, as I was saying, into two, right? I will have uh I'll have my options. All of my options, I will have them this way. All of my options. It means, where does the user input the length? Where does he input the loads? Where does he input all of those stuff? I will have them here. All right. And then the drawing, I will have the drawing. I will have the drawing of the beam and the representation of the load and the representation of the supports and all the line. I will have it somewhere here. Okay. So that's what we will do. And maybe there are times when we want to display the load, or we want to see the diagram, or we want to see the choice of modeling that we have done and all the like. Maybe I'll just create a section here like this for that. Okay. So I don't think I'll need much there. A height of something like 150 should do. Okay, we'll manage a height of 150 there for display information. And then the rest of the height obviously here would be what's that, 350. All right, so that's what I'll do. So let's just go and then start creating our interface. Okay, for that I'll need a new script. Good. So I'll create it as a function, right? I need to create it as a function because for the callbacks that we'll be seeing later on what happens when we do this and that and that. I'll need nested functions in it. So let's just create it as a function. And we'll call our function still beam. Let's just say still beam designer, right? Okay, so end. This is a good custom when you're writing code. When you write your function, just say end. Okay, so that you come back and then you write in the middle and you don't have any issue with ends again. You know that you have completed that one. At times when you just write it like that, and it can generate some errors and you will find difficulty solving them later on. All right. So steel beam designer, that's a nice name. Okay, so the very first thing we want to do is to create that figure. So we'll say figure, and as we said, position. So basically what I'm saying here is that we want to create a figure whose position is 0 following x from the origin, 0 following y from the origin, okay, 1000 of width, and 500 of height. Okay, so if I run this, I have to save it first. The name of your function has to be the same name with your file always. Okay, so save that. Let's wait for MATLAB. Since yesterday we're waiting for MATLAB. Good. So it gives us this. All right. So this file is what comes by default with MATLAB. Okay, with the MATLAB figure window. So you can remove that by changing its properties. So let's remove these things. Okay. So now we want a figure with menu bar. So we'll say menu bar. Should we say none? Is it none or off? I think it's off, right? Let's try that. Menu bar off. Okay, it's none. Good. So it's none. So now you see that the file and all the like they have disappeared. I now have my clean window. I want to change this. I don't want to be seeing this figure one appearing. I want to see the title of my software. Okay, so I will just say number title of. Okay, number title should go off first, right? So now the figure one has disappeared. I can now replace it with with the name that I want. So what I'm writing here is already becoming too long. Wow, you are not even seeing the off. Let me put it here, please, so that you can read exactly everything I'm writing. Good. So now you can read number title off. Okay. So the next thing I want to add is the title of the title of my figure, which is under the name property, and we'll say still beam design. Okay. So when I run this now, what do I get? That is it, still beam designer. All right. So that's what we get. So now we need to segment this window to suit what we have decided here. Okay. So we have display here. We have I don't know what we can put here, but anyway, here we have graphics. Okay, so it's a way of saying graphical representation, and in fact, we'll see how to go. Now, these things, they are not things that I don't know. It's not things to cram. These properties are not the like. Okay, if you go to the help documentation of MATLAB, you have all the information there. Whenever you're using a particular object, objects have properties, and those properties you can edit to suit whatsoever you need, right? So in the MATLAB documentation, which is still loading, if you come and you type, for example, we're using figure right now, okay? If you type figure properties, and you search that, um, so it should give you a list. It should give you a list of all of the figure properties and the corresponding values that you can use to edit your figure according to what you want. All right. So it's still loading. It's still loading. Wow. So let's wait for it to load. Okay. Let's wait for it to load. While it's loading, let's continue what we are doing. We'll come back to it. Okay. So we have figure good. The next thing is that we want to segment the way we have here, okay? And what I'll use to segment these different portions here is panels, okay? We call them UI panels. It is used to, okay? Okay, please give me one moment. Let me get something here. Oh, is that help not yet available? Wow. Okay, you can load for long. Sometimes I open a new page and type the research, it will be faster. Okay, okay, let me try that. Thank you, Brenda. Okay. Okay, wow, that's a good strategy. So you have mastered it. My God. Okay, good. So I'll click here. No, these are not fig. Yes, good. So these are figure properties. Okay, so for example, um, so this color property, for example, is one of the properties that we'll use very soon. Okay. Uh, Going down, we have the position here. We have the units here. I'm looking for the menu. So they are organized in alphabetic order, right? I want to show you some of the things that we already used just now. Ah, ah, have I crossed it? I cannot. I saw toolbar up there. Menu bar. This is it. Wow. So we're going down like that in vain. So this is menu bar right here. Okay. So you see that the value here, the property is menu bar, and then the default value is figure, and then we can set it to none. Okay. And it tells you what it does. Menu bar display specifies a figure or none. The menu bar property enables you to display or hide the default menus at the top of the figure window. All right. So the help documentation has everything. Okay. So just need to come and type and then read, and then whenever you see that you need a particular property, just come to the documentation and try to go through and see what property may be useful. You can also go to Google, okay, and just Just type there fast and something will happen. Okay, so UI panel. Now we have how many panels here? We have three panels, right? Okay, we have a panel for this part, okay, and then we have a panel for this part, and we have a panel here for this other part. All right. So what happens? We need to determine the position of each of those panels. So this one, for example, we have said is 300 and height 150. It starts where? At the origin. The parent here is the figure. All of them are measured from the parent figure. So if I have to display this panel here, okay, what I will have to do is to indicate its position. Let me call this panel, let me say display. I'll call it pan, then I'll say display. So that will be the name of my variable, pan display, okay, is equal to that. A way of saying that that panel is for displaying purposes, okay. So UI panel will say here position. We want it at 0 following x, 0 following y, and then the width, okay, the width here will be 300, and then the height here will be 150. All right, so let's display that. Okay, so as you see, nothing happens, right? Nothing has appeared here, and the reason is because the default units for UI panels are normalized, and we are working in pixels. Okay, so what you want to do first is to change the units. Okay, you want to change the units of the panel uh, to pixels. All right. So if I do that, then you see that we have a small ground flare this way now. Okay, these are small panel here. So we can put a title there. Okay, let me let me remove this for now. When I'll need it, I'll use it so that you can see what I'm typing. Okay, so we can put a title there, title, and say display. All right. So that's our title display. All right. So we can, let me just put it capital D, display. So that's what we have. So I see where our figure is appearing all the time. We are all, it's always there. It's annoying, right? So what we want to do is actually to move our figure. We'll move our figure by using the built-in function move g, and we'll say GCF, that will get the current figure, and we'll move it to the center. Okay, so that now when we are clicking, the figure should appear where? Come on. Okay, it's still coming. It is still coming. It is still coming. Wow. When? Good. It appears in the center. Okay. So that's what we want. The next thing we'll need. What happened? Okay. So our figure now appears at the center due to this command, and we have already finished with this panel, right? So let's just copy this, and then it enables us to create the other panel. What's the next panel here? The next panel is this one, right? Which let's just say we'll just put options there. All right, I'll just call it options, and we have to change the position. So where is it starting? This is the point of beginning of the panel. Okay, so we have to measure it from the origin of The origin of our figure. This is our origin here. So when does it start following x? It starts at 0. Okay, so we have no problem. Joseph, connection should be poor on your side. It should be poor on your side. The connection here has no issue. Okay, so it starts at 0, and then following y now. What is the position? It is at 150, right? And then what is the width here? It is 300. And then what is the height? The height is 350, right? The height is 350. Have I changed something? What did I do? Oh, here is 150. No, here is 300. What's happening? Here is 300 and the height is 350, right? 350. Good. Okay, so now we have our option here. Okay, so you can see that. And then what's next? A panel for all of this part, right? So that panel, where does it start? It starts here. Okay, it starts at x equals to 300. So we can copy this. Let me copy that and then paste it here. Uh, uh, so here we have, what's that? So let's show the position. Here we have 300 for the x position. Okay, for the y position we have 0. It has not moved up. And then we have a width of 700, right? A width of 700. So, and then we have a height of 500. Okay, so we display that. Perfect. That's what we get. Oh, we have to change the name to what? To graphics, right? We have to change the name to graphics. Okay. Perfect. So that's what we get. That's what we get. The next thing now is uh, I want to use this option actually to somehow start putting my menus. Okay, so we said we're starting with modeling, right? We're starting with modeling. I will not stress, okay? I will just put a pop-up menu here, a pop-up menu here. That will be the different options that I will be using. All right. So let me see what I mean by that. I will put a pop-up menu here. Okay. With that pop-up menu, I will say, for example, what will I say? Modeling. All right. So normally in within modeling, should I have to stress this much? Can this part not be the container of all of the information that we need? Because even at the level of design, in reality, we don't really need that much information. Let me see again what that looks like. We don't really need that much information. Uh, we need A at times, we need B at times, we need no. We need information, okay? We will need it. So let's just put in modeling for now. Or let me just allow the modeling and let's see how things goes. Okay. What I want to do now is I want to represent I want to put the length of the beam, I want to put the loading and all the lines. So this is what I have in mind. So I want the user to represent, I'll put the title something like geometry first. Okay, geometry, and I will say length. So in length, are they even seeing well? No. In length, the user will have to put in what is the length in meters. Okay, here we'll impose the units. We'll impose the units to meters and kilonewton, right? That's another scope that we have to choose there. Units are imposed to meters and kilonewton. So length that, And what again? Yeah, that's it. That's it. And then for the loading, we'll have loading, and for loading, we'll have the type, or should we say nature? Yeah, nature and type. In fact, nature. Okay, we'll say nature. Here we'll have a sort of pop-up menu. And in this pop-up menu, we'll have either live load or we'll have dead load. Okay, it will either be live or dead. All right. And what do I want to do with this? On the scope, we'll add to the scope that we'll be dealing only with live and dead loads. Okay, win loads will not be considered. We'll be dealing only with live and dead loads. That's added to the scope. So nature live load, for example, and then we'll have two options here, which I will make independent one from the other, or should I do it in such a way that the menu changes? Uh, okay, let me just say load type. So the load type also will have something like this. Okay, so you choose whether it is point load, uniformly distributed load, or no, let's just say point load or distributed load. Okay, we'll say point load or distributed load. He knows that if it is uniformly distributed, then cure one has to be equal to cure two. If it is triangular, he has to know how to model. So we'll try to look for a way to put an image there that describes all of the parameters that we have indicated. All right. So basically, this is what we want to see for a start. Okay, and then maybe we have an add button. We have an add button. So for example, if it takes point load, what do we need at a level of point load? We need him to enter the value of P. Okay, P will be in kilonewton. We need him to enter the value of A. A will be in meters. We need to enter the value of L. We already have the value of L, sorry. Okay, we already have the value of L. So we need him to enter the value of A and P. Okay, yeah, that's it. That's it. And then if he clicks on add here, we need the load added to the beam in the graphics, right? Yeah. And then if he comes here and he chooses distributed, then the option that will appear will be P in kilonewton, A in meters, B in meters. Is it even P? No, it is cure one, cure two, right? We have cure one, we have cure two. So all of these things are the things that we need to represent right now. Okay. So what I'll do, uh, we'll just locate where it can start. Okay, where it can start somewhere here, and then we'll bring it down, or maybe we try to just create it as though it's starting even here. Okay, we'll just create it. All right, and then we'll move it to its final position this way by translation. All right. So let me comment this part. I'll just call it geometry and loading. Okay, let's call it like that. So uh this can be a little bit, it can be a little bit complex, right guys? It can be a little bit complex. Okay, so I'll take the worst case scenario. The worst case scenario is this one. It will have longer elements. I'm not sure that cure one and cure two will even fit this 300 that we have given ourselves. That was given ourselves how many here? 300. Can we expand it? Let's expand it to 400 this way. Or pap, 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 pap. It should fit. It should fit. All right. It should fit. So this is our worst case scenario here. So what I will do is that I'll create an add button. Okay, so let's go. I'll say PB add. Add there, PB there stands for push button. PB add will be equal to these people. Yes, Chage, you're right. I can use the guide and design it directly, right? Unfortunately, if you can find me that code that converts the guide to that converts the guide to GUI so that I can use it very easily, I will be so happy, right? I will be so happy. Unfortunately, I don't have that code here with me, unfortunately. So let's just go like that. So I'll have UI control. UI control. The style by default is the push button, so we have no problem. But the string property there will be add. Okay. And what else? The string property there will be add. We need the position, right? The position add does not need to be that big. Okay. So we'll just say the code is not working with MATLAB 2018, Brenda. You've tried it, huh? It should work. It should work with MATLAB 2018. It's still MATLAB. So I want it to appear, I want everything to appear here. All right. So I'll just give it the distance that we have indicated. Where is that distance? 300. Okay, let me just say 350. It's just an initial distance, okay, just for us to start something and then maybe take it up 5. We'll translate all of these. The importance here is this part is the width, which will be 50 for now, and then maybe the height will take it to 20. So let me run that. Good. So I have my add button here. All right. So the next thing is this one, b that this value. Okay. So let's do that. So that will be a text button. I will have text. Wow, how would I call this? Text B. Let's just call it text B for now. I don't have inspiration. Must I even call it something? UI control. UI control. We'll have the string property to be B. All right. I will just say B with column. Okay. And the position now is what is important. Okay. The position now is what is important, and we have to change the style too. The style will have to be changed to text because this is not a push button, it is a text. Have I added something? Okay, good. So the position now, I will maintain. Let's take these values and then we'll see how to edit it. Now, will 50 do for all of them? Yes, actually, they are just, it's just A, B, B, da da da. So 50 will perfectly, it's even too much. It's okay, it will do for all of them. For the width, I mean, okay. For the height, we'll take the normal 20. Now, this B is supposed to be above this add, right? But the add has a height of 20 and it starts at 350. Okay, so what can we do? We'll just say 350 plus 20 and let's give it a spacing of 5. So 350, no, we're not here, 5 rather. 5 plus 20, 25, and 25 plus 5 gives us 30. So let me put 30 here and then let's see what that gives. Perfect. So we have a B here. All right. Now we need to put the edit text in front of the B. So for that, let me copy this line. Now the edit text is something that is a value that we will need. Let me say e text b. Okay, e text b will be equal to it is edit. It is edit. Wow, hey, thank you, Brenda. I did not even see that. Okay, good. So we have e text b that UI control is edit. The text there. Are we going to put any text there? No, let's just leave it by default, or let's put it 0 by default. And then position 350, no, 30 will be the same here, and we need to shift it, right? So the b here already occupies the 50 of width. Now we need to say 350 plus the 50. If we give it a spacing of 5 also, right, then it will be 350 plus 55 to give us 405. Okay, 405. All right, so let's run that. Good. So that's our b, papa. And now we need to, it's too far, eh? For me that's too far. Okay, let me try to bring it to something like 3, if I say 395, what does that give? What about 390? Okay, let's just leave it like that. 390. Okay, so that edit text is something I can come here and then enter the value for b, right? That's the meaning of edit text. All right, good. Now is the units that I need to put. Let me copy this and that. So here I'm saying this is, let me just be putting little comments here so that we know what we are doing. We should not get lost. B, okay. Here is the add button. Here is B. Okay, so here for the unit now, the style is still text, and our B will be in meters. Position, here we have added 40, so let's just add 40 to this other one too. That should give us 400 430. All right, and let's see, I'm sure it will even cover that thing a bit. Yeah, that's what we don't want. We don't want that. So in order to somehow overcome that, I will do this one. I'll do the e text after the unit, so that the e text will be on top of it, right? Yeah, exactly, something like that. So that's better because I don't want them to be too spaced away. This is the only place I'm writing. I don't need stress. All right. So it's finished, right? It's the same thing that we want to do now. We'll just translate it up. We'll just translate it up and change the values. It's the same thing that we want to do for A. So for A, we want this. I think that if we even succeed in sending this one, if we succeed in sending this one this way, okay, then we must have done something acceptable, right? So let's just send it. Let's just send this way to where it belongs. This add, let me try to. I will put add exactly under this edit text. Okay, so where is it supposed to be? Where does the edit text start? At 390. So let's put here 390. Okay. So yes, add is perfectly under the text there, and maybe for distinguishing purposes, let's even increase the space between them. Let me say 10. No, oh, what have I done? 5. To increase the space, I'll need to increase the y value this way. But let's forget about that. Let's first of all translate it to where it is supposed to be on that other side. So it's the position property that will change, right? Position property will change, and we need to mark the way it changes. So I want to bring this one. Why did we not just do it there? Oh my God. So the position property, let's take it, we'll have to take it, let's say we'll take it something like 50 away from here, and then 50 up also, or 30 30. Okay, let me put that at 30 30. Let's see what that gives. Sorry, what's the height? What's the height of this other one? So 30 here will mean 180, right? So here 180, that's what we mean. 180, so we are here. Yeah, something like this. And then we take this one now. We take this one up that way. So we said here was still 30. Was it? Was it? Okay, so for this one here, we'll say 30. Uh 30 plus 40. Okay, 30 plus 40 will give me 70. So that here I will have 30, here I will have 70, and here I will have 70 plus 40. That gives me 100 and 110. Oh my God, Brenda, thank you, thank you, thank you. My God, what am I doing here? Use the parents' property. Thank you, Brenda. Yes. Okay. So what we'll do here, because my God, look at all the time I'm wasting here ever since calculating these positions. Okay, so because all these things have to be found, let me show you guys. Because they have to be found in this panel, okay? Because they have to be found here in this panel. All right, this panel is the parent of all of these UI controls. Okay, so I can measure their positions from this panel directly. So all I need to do is to give this panel a particular name. Let me call it pan opt, right? Okay, and then I'll give them, so this I'll measure it from pan opt, and this, so when I put it as a first value like that, it tells MATLAB that this is the parent, this is the object from which you're supposed to measure the positions. Okay, good. So now I can work very, very easily. All right. So here I will just say 30 now. The 30 now will be very, very valid. The 70 here is okay. Uh, what else? Yeah, the 30 there. Okay, everything goes. So if I just run that, perfect. But where has add gone to? So you see that this one has come here immediately, right? So everything is cool. Where has add gone to? What did I do with add? 20, 30. Is there something wrong with add? 70. Okay, add is hidden behind the other one. This ones have to shift up, right? They have to shift up. So if this one starts at 30, then we have 30 plus 25 to give us 55. This, all of this is supposed to start at 55. All right, 55, and here 55. So perfect. Wow. Okay, good, 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 good. Thank you again, Brenda. Thank you, thank you, thank you. Okay, so that was B. Let's continue. That was B. So now we need A, right? So I'll just get this and then put A. UI control, da, 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 this is A. Okay. In metas. So now we need to change what? We need to change we need to add all of this plus 25, right? For it to go a little bit up. So 55 plus 25, that should be 80, right? So I'll have 80 here, 80 here, and 80 here. So that should give me my B, my A rather. So you see we have A now, da 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 da. So we are building, it's coming. So now we need cure one, okay? Cure one will be the same thing, right? cure 1, and here we have cure 2. Okay, so cure 1 and here cure 2. Cure 1 is in kilonewton per meter. Here is also in kilonewton per meter, right? Anything we are forgetting? Okay, we need to move them up. Okay, we need to translate them. 80 plus 25, that is 105. Here we have 105, and here we have 105. Here plus 25, I will have 105. Or should we shift this the way we said? Yeah, let's just say 105, 105 again. Okay, 105, 105 again, and then this one I'll shift it this other way. All right, or this one rather. We have 30 plus 50 to give us 80. Okay, 80, and then let's say a distance of 585. So this one plus 85 should give us this plus 85 115, 115. This one plus 85 195, and this one plus 85 155. Is that correct? Is that correct? Yes, I think it's correct. Anyway, let's check. It doesn't give, then fine. It gives, then fine. So there's a problem here, right? There is a problem here. And what could be the problem? See that I took the wrong index. So it was supposed to be 110 that we took as reference plus 50. Okay, that gives us 160. And then here we'll have 30 plus 160 to give us 190. Ha. Is that correct? No, 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 no. That cannot be correct. Uh, this cure 2 is supposed to start after this one, right? After this kilonewton per meter. So the kilonewton per meter is 150 it starts at 150 and then has a width of 50. So one at 110, sorry, has a width of 50. So that will give us 160, right? So plus 5 will give us something like 165. So I'll have 165 here. That's where cure 2 is supposed to start. Now 165 plus 40, okay, will give us 205, and then plus 40 again will give us 245. Does that give? Oh, 20. Here is 30. Let's make the distinction. Here is instead the 205. Here is 245 instead. 245, and here is 205. Right? From the way we exchanged things last time. Perfect. Okay, so that's what we get. That is what we get. Oh my god. Good. So we finish with this, right? We finish with this. So we'll just play with these values depending on what the user chooses here. If he chooses point load, then we'll make sure that B disappears and that Q1 becomes P and that Q2 disappears. Okay, we'll just play the game. We'll just play a particular game there. The next thing we want to put now on top of all of that is the type of load, right? So normally all what I'm doing now is loading. Where is that? Percentage. What I'm doing now is loading. Okay, so what am I looking for? Type of load. So load type, we need a text again. We need this thing. Chage, please, what are you not saying? Because I don't understand. Oh la la, you were not seeing the positions that I was playing with ever since, right? Oh my god. Maybe I should just reduce this screen to no. You were not seeing those positions. I'm really sorry about that. I'm really sorry about that. Let me try to remove this. Sorry. Let me try to remove this. Sorry. This. Okay. So those are the positions. Those are the positions. Really sorry about that, Chage. Wow. Okay, but anyway, these things are it's basic mathematics. It's basic mathematics. It's just addition and no big deal. So again, there we have three components. Okay, I'll just copy this three again and put it there. We have three components. One is the type. So I'll just say type, which is supposed to be the label. And do we even have three components? We have two components. So this one I don't need. I don't need you. All right. I need this guy, and I need it to be a pop-up menu, right? Pop-up menu. Okay. So that's what we want. The text there will be type, and the x distance in here, I will make it a little bit different. Let me increase 10 for this one. Now, for the pop-up, the string, we want the string to be a cell value. All right. It will be a cell of strings where we will have our different values. We want the live load. Okay. We want the live load. And then the next thing we want is the dead load. All right. So those are the two things that will be taken into consideration: live and dead load. Now we need to shift them up, right? So we'll add here plus 25. 25 will give us 40. Huh? Plus 25, 30. Mathematics. And here 30. All right. And if I run that, okay, the type is found this other way because I copied the positions of cure to. We need it that other way, not this way. And we even need to add it. Let's put it to 35 like that to make the distinction. 35, and then I'll copy here to be 30, and then this one will be 70. Okay. Okay, well, not really 70. What is that type? Okay, 30, let's say plus 50, we'll put it 80. All right. So now we have live, and if I come like that, I can choose dead. Okay, live, dead. Those are the two strings properties that I put there, as you can see. Okay, so what's the next thing we want? Hey, this is not live and dead. The type there is point. Is point and distributed, right? So we want it point, and we want it distributed. There's something wrong with me today. Distributed. And obviously, I'm sure that this thing will have to be longer because it cannot fit the word distributed. Let's look at that. So if I do that, I press here, will not really say distributed here. Okay, I would like it to be visible. So let me just increase the width. I will increase the width to something like 100. Let's just put here 100. Okay, so that if I take distributed, it is visible. All right. So let's copy the same thing for nature. Wow. Where is it? The same thing. We'll put it there for load nature. Load nature, okay. And then here I will have nature, and here I'll put dead before live, okay. Dead, and then here live. Position will shift up by 25 or by 30 to give us 65, and then here to give us what's that? Is it 75? Hmm? What am I doing? 65, right? So let me play this. Good. So we have the nature. Okay. So now we can put the big title there on top of all of these as loading, right? So let me just take this one. Just for title, just for the sake of loading. And in this particular loading case, I can change some properties, right? I can change the font size. We can put the font size to be larger. We can put it something like, let's try 30 and see what that will give us, and then we'll modify accordingly. Oh no, not 30. Let me try 18 and see what it will give us and modify accordingly. Font weight, we'll put it to bold. Okay. We'll put it 195. So let's look at that first. Oh, it's big. Okay. Okay, so I think that the problem here, first of all, if we are putting it 18, let's put it first of all, let's try to put it 12 and see what that gives. What does that give us? Loading. Okay. Uh, I'll put the position here to be something like 15 instead. And then we'll have to increase this one to something like 120. Let's see what that gives. Loading. We'll have to add another property. Let me do something here, please. So I think everybody is seeing what is happening down. So let me add another property here. There is something. Will I even write this right? Horizontal alignment. Horizontal alignment, right? And then we want the horizontal alignment to be left. Let's look at that. Good. So the title should be this way, loading. Okay. So we have loading. It will be nature, type, We could do this better. Okay. We could actually do this better. We could actually create a panel for loading alone. Okay, and then leave it like that. But you guys can still innovate. All right. The next thing we want to do is continue. Okay. Now we want to enter geometry and then fit in. Want to enter geometry and then we'll put the length and then we'll enter geometry similar to loading, and then with that we'll put an axis this way and we can begin to play. All right, good. So let's do that. For the length is very similar to the A and the B's that we had down. Okay, so let me be closing them. So let me just copy one A and B, all of this, come down. So, sorry. So now we are in geometry. We are in geometry, and the very first, in fact, the only thing that we have there is length. Okay. So don't mind this E text B. Okay. All of this E text B, will be changing them as we are programming. Okay. So I'm not forgetting about them. So where were we? At the level of length here. So we want our 30 to be there, no problem. So normally 30, 10, and 70 has no problem. The problem now is the height. 195. Let's add 30. If we add 30, we will be at 225. 225. Here we will be at 225, and here we will be at 225. Right? And then the text here will be length, which obviously we know it will not even suffice already. Okay, length, meters, so let's try to run that. Yeah, it will not suffice. So what we can do here is we'll shift the order to something like 2. Okay, so this way here, let me add something like 3, 8. No, is it on length? No, not on length, on the orders. And this is the height, by the way. So let me add here 8. Let me add here something like 8, and that should do. Good. So that we see the length clearly, we see there's the row, we see the meters and all the like. All right. So the title geometry here now will be very similar to what we have here. Okay. So this is geometry title, or let me say geotitle, right? It's Nyangalistic. And so here I will have geometry. I don't know why that space is in front there. I will have geometry, and then the height here will say 225 plus 10. No, 225 plus 30. What's that? 255, right? 255, and that should do. That should actually do. Perfect. So we have our geometry. So we have the representation of what we decided here. All right. So we have geometry. We enter the length. So the user will come here and enter his length. Okay. Okay. Once the 5 meters, he enter 5 meters. Okay. So before we continue with the beam proper that have to appear at the level of the graphics, let's try to see how this is supposed to function. Okay. So normally, as we saw, we can avoid errors at this level, because when we're doing the functions here, we made sure that the values of L and the values of A are valid values, right? Values of L and, but we can already prevent the user from making errors here. Okay, so we can put default values here. We can put default values at the level of all of these A's and B's, and make sure that those default values stay there if the user does not enter correct values. All right. So how are we doing this? How are we doing this? Why stress? In fact, let's ensure the minimum. Okay, let's just ensure the minimum at this level. Yeah, we'll default it to 5. We'll default A here to, let me feel inspired. We have the trapezoidal one here, right? So no, by default is the point that is first of all there, not even trapezoidal. Okay. So the very first thing, let's do this mechanism. When we click on distributed, all right. When we click on distributed, it should become P and A here. What we have here, it should become just P and A when we click on distributed. When we click on trapezoidal, no, when we click on distributed, it should be this. Sorry, it should be this when we click on distributed. And when we click on point, it should be just P and A, right? So if we've already put this one by default, then we can just start this one by distributed, right? So what we'll do is we'll come back here. We'll just change the position. Where is it? Where is it? Good, this one. We'll just change the position of this one. We'll do that. Good. So now we have distributed before point. Okay. So now when we click on point, it should give us just P and A before the other one. So let's try to implement that. Okay. So how do I do that? when I say that I'm clicking on this one, and it is on this pop-up menu that I'm clicking. This is the guy I'm clicking on, right? So it is when I'm clicking on him that something should happen. So I have to go and program his callback to make sure that when I click on him, something happens, right? Good. So where is this guy here in our code? This is him that we just modify, right? So we'll not call him a text b, or we'll call him pop. We must not even give him a this thing. We must not give it a variable name. But what we must give it, I'm already calling it him. What we must give it is a callback, okay? A callback property. So we have to give it a function that will execute when we click on it. That's what we call a callback. When we click on it, what function should execute? And we'll call that function load type changed, okay? Load type changed. All right, so now we need to create this function. We need to create this function. So I'll create it here inside the end, right? So in fact, let me create a whole section here for my callbacks. All right. So now I will say function, and the function name is load type changed. So this is the function that will execute when I click on that pop-up menu. All right. So I need the source. I need a pop-up menu in question, but I don't need the event. All right. I don't need the event. So I will say end. Now the source here is what? The source here is the pop-up menu itself. Okay. The source is always the object whose callback is executing. So it is the pop-up menu itself. So we'll say load type changed. What happens when we select? Okay, if we select distributed, we need to know that we're selected distributed. If we select type, we need to know that we're selected type, right? So look at this. By default, all right, when you're putting string data like that in a pop-up value, in a pop-up menu, excuse me, let me remove this. Okay, when you're putting this in a pop-up menu, all right, this will imply that the first value in the string in this is this one, and the second value in the string is this one. All right, so this pop-up object have a value property that goes from 1 right up to the number of items in your cell in your string here, and 1 will represent the first value, 2 will represent the second value, and so on and so forth. Okay, so what I need to do here is that I need to first of all get the value on which we have clicked. Okay, so what is that value? To get the value, I will say get, this is the object here on which we have clicked. Get that object's value property. So get the pop-up value property. Now we will switch the value property. Switch here is another type of if. Okay, if you use if val is equals to 1, it will still work. If val is equals to 2, it will still work. I just want to use switch. So I will say switch val. All right. Then we will say case. Case, for the case where val is 1, we will do something, and for the case where val is 2, we will do something, and that will be the end of our switch. All right. So let me confirm this switch. Let me confirm this switch syntax in the help documentation. Okay. So guys, everything that we are doing now, if you don't understand, first of all, you follow that playlist, and then the playlist will explain a lot of things that you will be able to understand easily from what we are doing. And let me get this. And you use the MATLAB help documentation, it should help. Yeah, so that's correct. You have switch, you have the expression that we are switching, and then you have case, you have the case expression, and you have the statement. So that's correct. Good. We can go back to our code. So in the case the value is 1, what does 1 represent? 1 implies that we are on. 1 implies that we are undistributed, right? Okay. We are undistributed. That's the first value that is there. Let me run this. That's the first value that is there. We have two values, distributed and point. The first one is distributed. The second is point. All right. So distributed, what do we want? We want all of these things to display. Okay, and we want to set the value of these things to be cure1, cure2, A and B. So ideally, we want to identify what are the objects that will change when we come to point. So let's all go to point before coming back to value 1. And when we are on point, it is this one that has to become P. This one will change to will remain A, but these two will just make them to become invisible. All right, we'll just make them to become invisible. How do we do that? Okay, so I was trying to find a way of doing it very easily, but without creating too many variables, without too many lines of code, and all the like. Okay, so listen, what we'll do is that we'll have an organization. Okay, we'll say the first we'll create an array. The array will not still work. The array will not still work. What if I give all of them a tag property? If I give all of them a tag property, I think that should do, right? So let's come up. Here we have A. A will not shake. A will always be there, right? So we have no problem with A. It will always be there the way it is. But Cure1 will have to change to P, okay? So all of these items on Cure1, let's give them a tag property. A tag property. Wait, let me try something, please. Okay, no errors. Good. So I'll give you the tag property of let me say this to say, or let me say point. Okay, for cure1 is supposed to change, so I'll call it point so that we know that that is what is supposed to be transformed when we are dealing with the point load. So I'll call it point, and then these other ones, if I call it point, yes, okay, let's just put it point for all of them, these three values, point, and then the other ones are supposed to change. Cure2 is supposed to be hidden, B is supposed to be hidden. So Cure2 and B are supposed to be hidden. So I'll give them a tag of distribute. Okay. I don't want a long statement. Let me just say this, right? Or dist is even better. All right. We'll give it here. We'll give it here. And what else? That's for Cure2. The other one that's left is B. All right. Let's see what we can do with that. So at the level of 2, let's sort of try to hide those two to see whether it's working. Okay. At the level of 2, we want to find all of those objects that have the tag of distribute and then hide them. Okay. We'll set them to visible none. So we'll say set, okay, find object. Set find object whose tag property is dist. You set their visible property to off. All right. So we don't want to see them. So let me run that. Good. So when we take point now, what happens? You see that those two disappear. Perfect, right? Pop up, they disappear. So it means that we want to do the opposite this way. When we come to distribute here, when we choose distribute, we want to do the opposite. We want it to be on. Okay? We don't want it off. So let's try that. So when I'm on point, they disappear. When I come to distribute, they should reappear. Are you seeing that? Point, they disappear. Here, they reappear. We want that. Good. The next thing now is that this cure one here, okay, this cure one here should be changed uh P, right? It should be changed to P. I don't know. Do I really need to do all this grammar of that for that to happen? I don't think so. Okay. Let me just remove this. Let me remove this. I'll just give it a variable name, right? We'll just give it a variable name to say let me just call it text L to say text load. Okay. A variable name, and from that variable name I'll be able to access it down. Okay, so this variable name implies that this is the object in question. Okay, so down this way I will say set um, that particular object set its string property to P, right? That's what we want. And then when it comes back to distributed, we want to set it back to cure one. Okay, we want to set it back to cure one. I think that will be right. So let's try that. Okay, so when we are on point load, PAP, that's PA. Are you seeing that? And then when we are on distributed load, it comes back to cure one, da 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 da. All right. So point load P and then distributed da 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 da. Okay. So they're asking for break. Okay, it's okay. You guys can have a 10 minutes break. So 10 minutes implies by my watch that we'll be back here at exactly 10:52. Okay, so go and relax your brains for 10 minutes and then we'll be right back. We'll be right back to continue. Okay, so see you guys in 10 minutes. Don't go offline, please. Don't go offline. It's not necessary. Don't go offline. So guys, are you back? We continue. Can we continue? Can we continue? I still on break. Okay, so we'll continue. Okay, good. So we've made sure that the point load. Okay, when we click on the distributed load, we have a corresponding value. We click on the point load, we have corresponding values and all the like. Okay, so the next thing we want to do. Okay, so for that, when you want to do graphics, everything that is drawn in graphics, whether it's a line or angle or whatsoever, okay, you have to use, oh my god, okay, okay, good, good. Sorry, I saw that my connection wanted to start disturbing. It has stabilized. It has stabilized again. So that's good news. Okay, so you want to use an axis, all right? And the axis is like this UI panels. The default unit of the axis is not pixels, it's normalized. So we have to first of all change the default unit. Then we can go ahead and position it. So obviously the axis will be positioned everywhere here, right? It will be all over this panel. So let's go ahead and do that. We are finished with geometry and loading. Let's just add the axis here. Let's add the axis here. So for the axis, it's just the axis command, right? And what we'll do is that we'll change the units, as we said, to pixels. And then change what? We need to change the position, right? To indicate where exactly it will appear on our interface. So we want the axis to appear here. Let me illustrate that. We want the axis to appear here, right? This is the part where we want the axis to appear. So the position origin will be somewhere here. So what we can do is we'll give our axis a parent property. Okay, a parent property of let's name that panel where it's supposed to be. The panel is graphics, right? So let's say pan graph. Pan graph is equal to that. Okay, so we'll say pan graph is equals to that, and then down here, parent, units, pixels, position. So the position now, parent will be pan graph, right? That will be the parent. Then units, pixels, and then position, we have 0, comma 0, or let's put it inside. Let's try to say 5, comma 5. And then what is the overall height here? 700 minus 10, width rather. 700 minus 10 should be 690. The overall height is 500. 500 minus 10 should give us something like 490, right? So that the axis is contained within. All right. So let's run that. What's happening? MATLAB is behaving unseemingly again. Huh? I'm waiting for it. It's as if it went on break too when we went on break. I'm waiting for it to come back normally. Come on. Oh, maybe there was an error. No, it's still executing. Wow. Okay, good. Okay, let's run that again. What is taking so much time? Oh my God. Wow. Okay, so heaven at last, it has come. So this is the axis as you can see here, right? And this is where we draw everything that we want to represent. But I'll have to shock you guys a little bit. We'll make the axis to be invisible, all right? We'll make the axis to be invisible so that what we see is only our graphics. So, but if we draw and it comes out there, you should understand that it's coming out there because there is an axis there. It's not because there was a panel there. It's coming out because there is an axis there. All right. So we'll just, and I think it will even help to even accelerate the process. So we'll have a visible off. Good. So while we are on axis, I think that, oh yeah, let me just put it as a percentage here to say graphics. No, let's take it as a different section. Okay, let's represent our beam. We say it's a simply supported beam, right? And let's give it a default length of 3 meters. So it means that when this thing opens, where is the length? This is the length here. When it opens, it should open with 3 meters default length. All right. So now at the level of beam draw here, we should be able to draw our beam. Okay, and then the beam will be modifying simultaneously as the user is also modifying it. So what we want to draw, we want to draw something like this, okay? Oh, it will not be easy, eh? It will be another task. We want to draw something like this. Must we put the length there? I don't think it's necessary. That can be extremely interactive, eh? Are we going to have time to do that? If at all we do it? Uh, okay, let's just say we want to draw this like that, three. All right, and ay, ay, ay. No, I'm imagining things in my head, right? But it will be overly complex if we implement that. If we implement that, but we want to draw our beam. We want to draw our beam, preferably with these particular triangles and this particular stuff here. Not necessarily this part down, okay? But at least that. So let's do. We're now diving to a little bit of graphics. So to draw the line first is not a problem. This line here is not a problem at all, right? To draw this line, all we need to do is what the coordinates, right? The coordinates of these 2 points. The coordinate of the point here will be 0, 0, and then here will simply be 3, comma 0. So all I will use here is my line function. I will say line, and then on line I have to indicate first the coordinates of the x-axis of the 2 points, which will be 0, comma 3, and then comma the coordinates of the y-axis of the 2 points, which will be 0, comma 0, right? And then what I want to do is change the line width. let's try it something like 2, yes, and see what it gives. All right. So we wonder, what do we have? Good, we have that. Okay. So that's the beginning. Now that line now on the first part we want to have, okay, we want to have our triangle. On the last part there we want to have our oh, la, 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 la. So how are we drawing that? So first of all, with the triangle, let's start with the triangle. I think we should just create a function that enables us to draw that. All right. Yes, that will give us a function that will give us the final object, which is the triangle. All right. So this is our triangle here. Okay, it's very simple. All we need to indicate is this height here and this base here, right? If we have a first point here, the second point here, and the third point here, and we assume that this point here divides the triangle into two, okay? Then let's call this A, and let's call this a certain B. All right. So all we need to do, we want the coordinates of this point A, of this point rather. Let's call this point 1, point 2, point 3. Okay. I just want the coordinates of this point 1. The point 1, I want its coordinates. Why? Because the coordinates will tell me where I will place my support. Right. Good. So let me create a function. We'll call the function triangle draw, and in fact we'll say z is equals to triangle draw because we'll need the output to be the object itself that it has drawn. Okay, and then for the input we want the point. Let me just call it point. This point here, the coordinates of this point. Okay, the x comma y coordinate of this particular point here, and that's it. If we have that, then we can tell where it starts. All right. So from the coordinates of this point, what can we do? We can have a coordinate matrix. Okay, I'll call it called, will be equal to, we can have a coordinate matrix where the coordinate of the first point will be that point. All right, will be this point. Coordinate of the first point. Coordinate of the second point, I'll just put semicolon. Coordinate of the second point will be the coordinate of, this is the second point here, right? So look at this. This is the first point. For the second point, the y coordinate of the first of the second point is what? Is the y coordinate of the first point minus a. Are you seeing that? Let me call here a, not b. A. It will be a everywhere. It will be, so here we will just say a is equal to something, right? Let's assume that a. We say the length is 3 meters, right? So let's assume that a will be something like 0.2. A very small value like that, 0.2. So point here, let me put a comment so that you understand. Point here will be something like this. It will be something like this, x comma y, right? We just want the x comma y coordinate, right? Now if I come here and I put point, it means that I'll put this x and y coordinate that I entered here as the first point. The next will be the coordinate of the second point. The x coordinate of the second point, okay, is what? Is the x coordinate of the first point plus a on 2, because here we have a on 2 and here we have a on 2, right? So I will just say point of 1, which means the first coordinate, plus a divided by 2, right? And then comma point of 2 minus a. So that should give us what? That should give us the y coordinate of the second point. It is the y coordinate of this point minus a, right? Good. So what about point 3? So we'll go semicolon and then point 3 now. Point 3 will be identical, just that point 3 is minus here, not plus, right? It is point that minus a on 2, not plus a on 2, and then We have the same thing here. Good. So those are the three coordinates of that form my triangle. When I have that, then my z will simply be equal to patch, right? Patch of chord, what am I saying? Part of vertices, right? Vertices, chord, and then faces. The faces will just be 1:3, right? Yeah, 1:3. 1, 2, 3. Those are the faces. And that's that. Let's change the, let's put the face color red. Okay. Face color. Let me just put it red. All right. So that will be my Z. So what do I do now? Here, I just need to use this function, Control C, right up here. Okay. So on this axis, we'll make sure that when we are plotting a new thing, because here we'll plot the line. Okay. By default, if I plot a different thing on the axis except from the line, it will erase the line that was there before. So what I want to do is I want to add a next plot property, to my axis, and I'm telling it that for the next plot, don't replace. Okay, by default it is replace. For the next plot, you should add it, don't replace it. Good. So now I'll just call that function here the triangle draw of point, and our point here is where we want to apply the fixed support at this level, right? So we'll just put there 0, 0. So yeah, 0, 0, 0, 0, 0, 0, 0, comma 0. Okay, so let's see what that gives. Ooh. Ooh. It has replaced. Okay, it has replaced, even though we said add, don't replace. Let me see. It has replaced. So in fact, I don't know why it's replacing, but let's just go ahead and use a hold on. It's not a problem. But it's supposed to add, not replace. Let's look at that again. Why is it replacing? Okay, let me see something, please. So axis properties. So remember, everything I'm doing, you have to apply it with the fixed support, right? With the cantilevered beam. So a beam, like that, right? I want to see that next plot property. Ay, ay, ay. Documentation is long for me to find that thing now. Another work. Anyway, we'll correct it. We'll correct it later, right? Let's not waste a lot of time on this. So let me just put hold on for now. Okay, hold on does the same thing. Hold on does the same thing. So let me put hold on for now. Hold on does the same thing, and it has replaced it again. Does he hold on and then forget? What's happening? Okay, so let me try here. Let me try to put the hold on here. Wow. 3, 0.2, That should not be that much. What's up? Oh my God. Okay, so let me try something. Okay, let me just try something, please. Let's put all of that back. I've seen that is not explode that was the problem. Let me see. Let's try to put axis equal and see what that gives us. Okay, perfect. So that was the problem. Okay, our problem was axis equal. Okay, so yeah, perfect, perfect. So that's a triangle. For me, it is a little bit too big. It's too big now, guys. So let's try to put it 0.1 and see what that gives. A to 0.1 and see what that gives. Yeah, something like that. Something like that is acceptable. Okay, so to save time, okay, to save time, I will not put where is it? I will not put a roller support here. Okay, we'll just keep the same triangle this way because to save time means those circles. Let's just run away from them. We'll just put the same triangle this way. All right. So to put a triangle that way, you guess that I just need to indicate what the coordinate of that other point, right? So I'll just say triangle of what? Of 3, right? Of 3, comma 0. And that's that. So you see that I've created a function where I just need to indicate the position where I need my triangle to appear, and then it draws the triangle from that position downward. As simple as that. So now we have a beautiful beam which is 3 meters. Okay, we need to indicate. I think that we need to draw something that indicates this dimension. The dimension this way. I don't see. I don't the dimension this way, or would it be necessary? Let's leave it for now. All right, let's leave it for now so that we can progress and advance. We have more things to do. Maybe we'll do that in a later time. In a later time. So what we want to do now, all right, we have our beam, so it means that uh, we are good. We are good. So when we run our application, it comes with the simply supported beam. We are okay, right? So the next thing that we want to do is to make sure that the length that is entered here is always correct. Okay, so that we are finished with length. Normally, I wanted us to indicate this span here because we need to be dynamic about the way we are doing things, right? This, all right, so that uh, when the user changes the length here, okay, when it changes the length here, normally the length here is supposed to change automatically as he has changed the length here, right? We're supposed to see it in the graphic. So it means that this graphical representation should always be a representation of the data that has been given this way. Okay, and that's the difficulty with applications, is that you have to anticipate. One step can take you something like 1,000 hours. I don't know how to put it. Okay, so at the end of the day, I think we'll do that. We'll do that, or maybe we'll just use marker sizes. We'll put a line down there, and then we'll use marker sizes. Okay, to indicate that. So that line can be fixed for now. Fixed for now, but then as we're editing, it will just go. So it will not take us time. All right. So let's just do that. So we have this line here, which is the line of the beam. We can represent another line, okay, under the beam. So we said that our triangle is taking something like 0 point, but we have to be careful because, yeah, anyway, to be realistic, the spans will go from something right up to 10 and all the like. If I put 10 meters here, would it be that bad? Let me put 10 here and I put 10 here, for example. I want to see whether the triangles will be too small if we maintain a constant value of 0.1, or we need to vary the value of the triangle to, it becomes a little small, right? So what is the ratio of 3 to 0.1 so that we can change the value of the triangle together with the length, so that we always have a consistent triangle. So what we are saying is, when we were using 3, when we use 3 meters, we use a triangle of 0.1. All right. So now we want to use, for any x meters, what will be the corresponding a that we'll be looking for. Okay, what will be the corresponding height of the triangle that we'll take, so that we always have that particular. So it's just to cross multiply, right? We are saying 3a will have to be equal to 0.1x. Okay, so a will be equal to 0.1 divided by 3 times x. Okay, so a way of saying that for that our triangle function, we'll just have to add the length. Okay, we'll have to add the length as another property. Okay, so let's just say comma 3 in this case by default, comma 3, and then in our triangle function, let's add the length L here. Okay, and then here the function will be 0.1 times what? Times L, right? Times that length L. All of that divided by 3. Okay? Even though I don't like 3. 3 is a very bad number. Let's use 4 as our default, please. But you at the moment will give us 0. Yeah, that's it, Brenda. What you wrote there, 3.33%. I don't want that. So let's have it this way, and then let's see what that gives. So let's sort of see what it gives by default. No. Let me put it back to, excuse me. Let me put it back to 3 first, okay? 3. Yeah, 3. Let me put it back to 3 first. Yeah, acceptable, right? At 3 it's acceptable. So now let's look at it. When we go to 10, what does it look like? 10, it has to be 10 now our length, and 10 here our length, okay? So what does it look like now? Exactly. So you see that we have exactly the same triangles, irrespective of the length, right? We have the same triangles. That's what we want. Whether it is 10, whether it is, the triangle should not reduce. Okay, perfect. So let's put back at 3 default there. 3. Okay. So normally we could even use the same function, okay, to do that labeling, because the labeling also will depend on, we want it to be the same, okay, irrespective of how the beam is. But let's just do something here now. So we'll have a line. Uh, uh, ay, ay, ay. The length L will always be the length of the beam, right? It will always be the length of the beam. So why not we say that this triangle draw just comes with that particular labeling that we want down? Let's put it like that. So it means that we will just represent this line that we want to draw down here. Okay, this one. We'll just represent it inside this very function. Okay, we'll just put it here. All right. So here, line 0 right up to L, which is the length of the beam here. Okay, from 0 to L, and then now here is what we have to change. So the line normally is at 0, 0, but we want it down first of all A, okay, which is the height of the triangle, and then maybe down something like 2 times A. Let's put it like that. So it means that down A, down 2 times A. So let's say down 3 times A. Okay. So we'll say the Y here will be 3 times A, and here again 3 times A. Okay. So normally it means that I don't really need this Z here. Okay, I don't need the Z there. If we need it, we'll see how to get it. So let me run that. What happened? Eh? Ah, okay. Something happened, right? Here is 3, it's not 10. Okay, so let's run that. Ah, okay, so it's negative. This line is supposed to be under. Okay, it's negative. So let's do that. That's great. Let's do that. So this is minus and then minus. And we'll play on this line. Okay, we'll remove this line with. Remove this line with, and what we will do is that we will just put the marker. We'll put marker. Let's put marker X. This one. And we'll put what's that, the marker size. We'll put the marker size to be, let's put something 2 maybe times a. We have to put something times a. Let's see how it varies, and then we'll be changing accordingly. All right, so let me run that again. Okay, so the 2 times a is extremely small, as you can see, extremely. So let's try to increase it to something like 50, right? And let's see what that gives. Okay, 50 times a is already coming. So normally I want to use these markers to say that it is from here to here, right? I don't want to put those lines there. Let's take advantage of the markers. Let me use 100. Good. So 100 tells us that the beam starts here and it ends here. So the problem now is what is the distance, okay? Is the distance that we want to indicate. So we'll put that distance in the middle of the beam, okay? So to do that, I will use the text function, the text belting function. I'll indicate the x and the y coordinates where I want my text to appear. What is the x coordinate here? The x coordinate will be L divided by 2. Alright. Okay, say alright. Okay, what is the y coordinate? The y coordinate is this one. Okay, and I have to indicate what the text in question is. The text in question will be the length itself, right? So we'll say num, because the length is a number, but we need it in string, so we need to convert it to string, num to string of L. All right. So if I run that, what does that give me? Let's see. Good. So we have 3 here. Okay, we have 3. Now we want that 3 to be on top. Want 3 to be on top. I think that text has vertical alignment, it has horizontal alignment. Let's try that. Bottom, top, left, right. Let's try. Okay. So let me say vertical alignment. Vertical alignment, should we say, if I say top, what does that give me? Does it even work? Good. So top, the opposite. So what I need to say is now bottom, right? And I'll be good. Okay. Perfect. So that's our guide there, and we are free. I can put M here, right? As a concatenation, I can come and concatenate here and put M. Okay. I can concatenate here and put to say meters, right? And put M to say meters. All right. So that's perfect. That's really perfect. Now, when we edit our length here, we have to be able to see it editing also here. Okay. Oh, they are not seeing the end of the beam. Oh my God. Oh my God. Again. Sorry. Good. So I hope now you're seeing, Joseph. Thank you. The rest, the guys were quiet. I did not understand. Do I understand? So now the length is 3 meters. Okay. So Now, when I come here and I edit the length here, first of all, we need to make sure that the user cannot enter any negative number here or the value 0. You should not be able to enter that. You should be able to enter a positive numbers only. So let's go ahead. So what happens? It is when we edit here, right? That something should happen. If I press 5 here, that's when something should happen, right? The length here should change to 5, and here should change to the corresponding 5 meters. All right. So how do I do that? How do I do that? I'll simply give this e-text a callback. Okay. So let's do that. E-text, 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 e-text. Where is it? Where is the length? This is the length here, right? So let's call it e-text length. I'll just call it e-text length like that. All right. So that I can manipulate it. Or do I even need that? Do I need that? Do I need this? Not for now, okay? We'll give it a variable when we need it. We'll give it a variable name when we need it. I don't need it for now. Okay, so I'll give it a callback property. So what happens when, that's what the callback is, right? What happens when we edit the text? What happens when we edit the text? Okay, callback, callback, we'll give it a function. Length, we'll say length changed, okay? Length changed. Okay, there is a function known as CLA. I think it's clear axis. We'll try that. We'll try that just now. Because what I want to do is than to modify the existing beam, I can clear the axis and redraw a new beam. Okay, and redraw everything afresh. Because from there, changing the X data, changing that, you will not kill me anyway. Will it? No, let's go, guys. So, this is the function that we need to create. Okay, to control what happens when we change the length. All right. Sorry. Function that, and then the source. We need the source because we need to get the text that is written inside inside the edit text. Okay, good. So what's the first thing that we need to do? We need to collect the value. When the user comes and types there, we need to collect that value. Okay, so to collect it, I'll call the value str. It will be equal to get what? Source here represents the text itself, right? And everything that the user types is stored in the string property of the object. Okay, so when I get what is in the string property, I get the value that the user has typed there. All right, so that value that he has typed there, if it's 3, string will be equals to 3. If it is 2, string will be equals to 2. Now when I get it, it will be in a string format. What I want to do now is to convert it to double. Double means to a number. Okay, so I will say string to double of what I have collected. Okay, it will convert it and I can save it inside a certain val, right? To say that's my value. String to double of da 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 da. Now, if what the user entered there is, for example, Loic, if somebody typed the Loic, okay, what will happen is that this string to double, let me do it briefly here. If I do string to double of the text Loic, okay, it gives me none, not a number. All right, so there's a number of checks that I need to do here. Okay, I need to check if is none. No, we have to make sure that it is not none, right? If it's different from none, if it's different from is none val. So is none is a built-in MATLAB function that checks whether a particular value is none or not. Okay, so if it's none val, it will be true, and then this one is a negation. Okay, so I'm trying to say that if it is not none, and so a number of things need to be checked. If it's not none, and and val is what? Greater than 0. These are the conditions that need to be met for us to accept that length was entered properly. It does not have to be null, and the value there has to be greater than 0. Okay, then what should happen? If it is not null and the value there is greater than 0, then something has to happen, right? That's when we have to take into consideration what the user has entered there. So what we want to do is we want to clear the axis of the drawing that was there, and then we want to redraw this beam with all of these parameters. All right, we want to redraw all the parameters, but the length now will be what? The value that the user has entered, which is val. That will be the new length there. Okay, so let's first of all try that to see that it's working. Okay, so let's run. So now the length is 3. Let's say I enter L. What happens? Nothing is supposed to happen. Nothing happens. If I enter 0, what happens? Nothing is supposed to happen. If I enter 5, what happens? Nothing has happened. Hey, are we safe? 5. Thank you. Okay, 5 has happened. There's a problem, right? There is a problem. There is this triangle that has not moved. Okay, so what happened? Okay, here it needs to be val also. Okay, it needs to be val too. So let's do that again. So if we put 5, okay, and I press enter, that's it. That's changed to 5, right? If we put 2 and I press enter, it has changed to 2. What about 1? It changes to 1, but then these markers become too small. Okay, no problem. We can manage it like that for now. And 10, how do this marker become bigger instead? How do they become bigger instead? We need to apply a similar formula there in such a way that the same way the triangle does not change, it's the same way the markers don't have to change. Okay, the markers don't have to get bigger or smaller. You see that the triangles they are practically the same, right? Even if I put 78 meters, the triangles don't move. They are still the same because there is a proportion. There is something that has happened. So a similar thing needs to be done here. So maybe it's because this 100 is fixed. We take 100 to be the value. How can we do that? Anyway, we'll brainstorm that. Okay, we'll brainstorm that. It should be something similar to what we'll be doing. For now, for the acceptable ranges of a beam, I think the drawings are okay. Okay, for now, for the acceptable ranges of the beam, I think the drawings are okay. So let's accept what we have for now. So we have 10 meters, we have 5 meters. Okay, so what if what he enters here, for example, Loic is not valid? What do we want? We want it to come back to the value because the value that is here should always be synchronous. Okay, it should always be synchronous with the value that we are having here. So what I will do is I will use the user data property of the object. So where is that length that we had here? So we'll store the previous correct value in a particular property in the object. So we'll say user data. Okay, user data. I'll put it user data. We'll put 3 because 3 here is the initial length. Okay, so we'll put 3, and then here, if what he enters is not correct, okay, we'll set the string back to the correct value that was there before he entered whatsoever. Okay, so we'll set source string property to get source user data. Okay, user data. That's what we want. And then here, normally, if it's correct, it means that we have a new correct value. Okay, a new correct value implies that we need to set source user data to the correct value, right? Which is normally num to string of val. All right. So let's see that in action. So when I run this, if I type Loic here, it should come back to 3 because Loic is not correct. Are you seeing that? It comes back to 3. Loic is not acceptable value. If I type -3, it should come back to 3. But if I type 5, 5 is the correct value. Okay? Now, if I come and type, for example, 0, it should come back to 5, the previous correct value that I entered. Okay? So this is an acceptable way so that we have these two here that should always be synchronous. Okay, so now we enter the difficult part. It's a little difficult and very, very tricky. The difficult part, which is this loading, right? So we're not really concerned now with whether it is a dead load or a live load or da, 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 da. We are concerned with whether it's a point load or a distributed load. All right. So when it is a point load, okay, and we click on add, we want to see our point load added here at the distance that we have specified here. Okay. If it's a live load, we want to see our live load. In fact, not live load but trapezoidal load. If the trapezoidal load, we want to see a trapezoidal load added here at the distance that we have specified here. So let's try to go from easy to more complex. All right. So let's start with the point load. So what we'll do is that we'll specify a kind of function. That's what I'm thinking now. That will enable us to draw the arrow that we want. Okay, that will enable us to draw the arrow that we want, and then we'll use it. I don't know what else is there to say. And then we'll use it, right? So let me let's analyze together. So the point load is represented by an arrow, right? So if the point load will be represented by something, by an arrow. Okay, so the good thing is that we know the point of application. We know that the arrow is what always touches the beam. Okay, so this is the point that we are interested in. We need to be able to draw an arrow. No, let me yeah, let me put it in the positive sense, right? It's okay. You need to be able to draw an arrow. All right, and from a particular point here that has been indicated. So what we need to know is the magnitude of the arrow here. The length here will not always be the same, right? It depends. When it is, if he represents a force of 10 kilonewton and then represents a force of 8 kilonewton, the height of the arrows should be able to tell us that this one is 10 and this one is 8. Okay, it's not the same height for all of them. The length of a particular arrow represents the magnitude of the force. So here I will say, should I say P? Hmm? P? Okay, let's say P, right? So we'll indicate the value of P normally. And we'll need the coordinates of this point. If I call it point 1, we'll need the x1 and y1 of this point. All right? So let's try to just start creating the function and then we'll see what we can do about it. Okay? So function I will say point load draw. Let me put something like that. Okay, so what we need is the point the point there where the arrow will be placed, the point from which the arrow will be drawn, right? That's what we need first. Am I correct? Yes, I'm correct. The point from which the arrow will be drawn, and then we'll need the magnitude of the load, okay, P, and is there any other thing we need? I don't think so. All right. So let's say for this arrow again, we'll give ourselves a height of A and another place here of A. Okay. What are the points? What are the points that delimit this particular arrow? We have this point and this point and this point, right? Those are the points that form the arrow. This one, this one, this one. So we have to be able to measure each of those points from this one, from point one, because it is the value of point one that we have. Okay, it is a value of point one that we are having where the load will be applied. We have that. So again, the point there will be just like this one here. We have the x and the y axis. Okay, so in this case, how are we doing about that A? Can we take the A to be the same? If we take the A to be the same, no, we'll not take the A to be the same. It will be something similar. It will be something very similar, but then we'll need to do something about it. We'll do something about it. And then this height here normally is not P per se, right? Because we cannot represent it as P. Let me explain. Uh, for a beam, for example, of 3 meters, right? I may come there and indicate a load of something like 20 kilonewton. If I indicate 20 kilonewton and you want to represent this length here as 20 because I have said 20 kilonewton, there will be a problem. Because your 20 will want to be too long that it will make the graphics to look extremely ugly. So we have to bring it to a certain scale. Okay, so maybe we will say that we want, no matter what happens, we want the highest length of the maximum force to always be 1. Okay, and then the others will vary between whatsoever. We can do that. So that's the importance also now of interpolation that we'll have to apply here. We force it to be 1. We force the maximum value to always be 1, and then the others have to follow according to the value of the maximum value. I digress, right? We are coming. Let's go bit by bit. But I'll call this length here. We are in the local coordinate system. We are local here, okay? Inside here we are local. So it means that the variable A here is not the same as the variable A here. It's not the same thing at all. The A here was for this function. This A here is for this other function. It's not the same thing. So I'll use an L here, which is for this function. I will call it L, this one. We'll call it L. So L will be a particular measurement of P, right? It will be a measurement of P. So let's even give them constant values for now. We'll see how to modify them later on. Let me give it 1. Just for us to see that the load is coming out first. When it comes out, we'll see how to anticipate and make it even better, right? So I've called this point 1, and that is the point that I'm indicating. So let's call this point 2, let's call this point 3, let's call this point 4. Okay? So point 1 is x comma y. Point 2 now, what will be point 2? It's simple, right? If we assume that this one is in the middle of these ones and that this is A, point 2 is very simple, right? Point 2 will be let's just write it there. I don't know why we're wasting time here. Chord will be equal to, we first of all have point 1, right? Which is point. Okay, and then point 2 now will be the x value of point 2 will be the x value of point 1 was plus, are you seeing that? Plus A divided by 2. All right, and then the y value of point the y value of point 2 will be the y value of point 1, which is point of 2, as its y value, and then minus, okay, minus what's that, minus a, right? Minus a, which is this height here. Minus a, this height. Okay. Good. So point 3 will be something similar. Point 3 will be something similar, except for the fact that here I will have minus a on 2. All right. And then what about point 4 now? What is down? What is down? Point 4. Point 4 will have the same x-axis as point 1, right? So it will be point of 1, the same x-axis. But then the y-axis is what? Point 1's y-axis, which is point of 2, minus L, okay? Minus L, that's what it will be. All right, so that will be my chord. So for the connectivity now, we need a connectivity, because here the shape is not really continuous, like the triangle that you say 1, 2, 3, right? We need to connect the lines independently. So for the connectivity, the first line here we have 3, 1, okay? 3, 1. The next line we have 1, 2, 1, 2, and then the other line we have 1, 4, right? 1, 4. Okay, so what we can do now is we can patch. Okay, I'll just copy this patch here, and replace by the corresponding values. Here we can use edge color instead of face color. Okay, so because we're dealing with edges here, not necessarily with faces. Or let me see. Let me try face color and see what happens. Face color. Faces, vertices, chord, and here con, right? Yeah, and that's that. Okay, so I'll not use P here. Mm, okay, let's leave it like that for now. Okay, let's leave it like that for now. Or let me even remove P for now. We'll change it as we go along. So how do I use this function now to check whether it's working, right? So it depends on the add button, right? So when I'm on my interface, when I'll indicate my point load, I'll indicate a P and I'll indicate a A, right? This is the A that will enable me to know the coordinate of the point where I want my point load to come out, okay? And this P will actually tell me whether my load is positive, whether the arrow is supposed to be like this, or the arrow is supposed to be like that. So I think it's something that we need to take into consideration here, okay? So let me just put P here, and we'll do 1 times sine of P. That's what we'll do. So the sign of P will tell us if P is positive, it will be +1. If P is negative, it will be -1. Okay? So yeah, we don't want it to be the actual value of P. So let's try. So for us to try that, we need to program this add function. Right? What are all the oofs for? We need to program add function. So once we have entered the value of P, we have entered the value of A, we need to program the add function. So let's go to add and give the add a callback. What happens when we click on the add button? Okay, so add. What was that add? It was the first thing, right? So we'll give it a callback. We'll give it a callback. Let's call it yes, it's add load, right? Let's call it add load. So it is in add load here that we'll use that function, right? So function add load. So this function is what will run when we click on the add button. So we'll click on the add button. What do we want to see happen? When we click on the add button, we simply want we want to get the value of a, this value of a here. Hey, we want to get the value of a. You know where the value of a is, right? Okay, so we'll just go and look for that a value of a. Where is it? We've given it e text a, right? So let's call it e text a. So I'll get the value inside this e text a. So to get that, it will be a, let's call it a, will be equals to, so remember, the a here now means the value of a, that distance where the load is applied from the original position. This a here is not the same as this a, where I'm in a different function. Local, okay, definition, the a's are not the same. So a here will be equals to um, get e text a, right, which is that edit text, get what, the string property which is there, okay, get the string property which is there, and then we also need the value of p, right? We'll say p will be equal to get e text p, the string property which is there. So we need to call that other one. We need to identify p here and call it e text p. Where is the p? Be careful. It is cure one that changes to p, right? It is this cure one that changes to p. So let's just call it e text p. It's okay. E text p. Okay. So e text p. So once we have a and p, we can now call this function, right? For it to draw. Okay, but at what point is it supposed to draw it is the question. Okay, so it's supposed to draw it at x is equal to a, right, and at y is equal to 0, exactly on the beam. Okay, so let's see that this is supposed to work. We're even supposed to program. We're supposed to program this in such a way that we have these two in such a way that we have values that are less than L and all that. But we'll see. We'll see. So let's go to point load. And in point load, the way I've programmed add is just for us to see how to add this load, okay? Because normally add is supposed to identify, we are supposed to have a switch condition there. We need to get, are we in the case of adding a distributed load or are we in the case of adding a point load, okay? We need to get those two. And if it is a distributed load that is a dead load, we need to multiply it by 1.4 before adding it. If it's a distributed load that is a live load, we need to add it by multiply it by 1.6 before adding it. Right? So we'll take all that into consideration very soon, very soon. So let me just put any load. The load does not really matter. Now it's just the sign that matters. We want it at, let's say, a equals to 1.5. Let's put it in the middle. Add DJ. Oh, we have a ping. Okay, so let's check what the error is. What happened? Called point. It seems like there was a problem with the vertical concatenation. Let's go and see that. Let's go and see that. Take me there. Good. So I have point of 1 plus a on 2. Yes. Point of 1 plus a on 2, comma, point of 2 minus a, semicolon, point of 1 minus a on 2, comma, then semicolon, point of 1, comma, point of 2 minus 1. Concatenation. Where is the problem? How is concatenation a problem here? What did I do wrong? Let's read that error again. Dimensions of arrays must agree. Called is equals to that. It's technical. It's really technical. I'm not seeing, these are the kind of errors that I'm not seeing where the error is. This point normally is something like that. So we should have no problem there because that's the way we called it. We have called it with something like that with a comma 0. And a here is just, okay. Uh let's convert this. It has to be string to double, right? Rather double, huh? Yeah, string to double. Because what we are getting is in a string format. Okay, so let's try string to double. String to double of both. And see whether that was the problem. Okay. So we say we have put what here, point load. It does not really matter for now. 5. And let's put here 1.5. Good. So you see that, right? So it's something like that. That's where the load will appear. But now that load is too, you see that. So imagine this is just 1 meter and look at the way it has pushed. I've just put one there. Look at the way it has pushed. I was talking about 20 kilonewton. Imagine that it was taking this 5 kilonewton literally and that's what it was plotting here. It will have been something else, right? So but let's see. I now want to apply it at 2 meters, but then I want the load to be negative following the, okay? So negative that. Let's add. Perfect, but there is a problem, right? It's perfect, but there is a problem. And what is the problem here? What is the problem? The problem is that A is not intimately connected to what? To P, okay? So let's look at that. So the same way we have this times sine of P here is the same way we are supposed to have this A times sine of P, okay? So that everything follows. Times sine of P, all right? So let's try that again. So point load 5. Let me put 1 first. Good. And then negative 5. Let's put it at 2. Perfect. Right? So we have that. Which is not sufficient. So now we need to go back and you understand, uh, do some hoity-toity bugaboo. So do we focus on add first, or do we go back and make sure that the arrows are coming out the way they are supposed to come out? So let's finish with add first, okay? Then we just come back. Let's finish with the point load aspect of all of this, okay? Finish with the point load aspects of all of this stuff, and then we'll come back and do so in add load. In add load, to say that A is equal to that is not enough. It's not enough. We need to be able to, what's that? To know whether it was a point load that we added, or a point dead load, or a point live load, or a point trapezoidal load, or a point, you understand? We need to know, okay? So for that, we'll get the value of those stuff. Let me run this again. So here we need to know whether it's a distributed load or a point load, right? So the value, you remember this thing, okay? If I get the value property, if the value is equals to 1, then it's a distributed load. If the value is equals to 2, then it's a point load, right? But then I need to get this particular object here, and the particular object is somewhere up. Where's that pop-up menu? Pop up, pop up, pop up. Where are you? Where's the pop-up guy? Okay, this is the pop-up guy. Okay, so we can say pop pop type, right? So we'll say pop type is equal to that. Okay. Where does it end? Okay, pop type is equal to that, and then the other one, there's also a pop-up for nature, right? Where is it? This is it here. So we'll say pop nature. Okay. It's just my way of naming things, okay? I like to know the kind of object I'm dealing with. If it's a pop-up menu, I will say pop first before giving a name. If it's an edit text, I will say edit text first before giving a name. If it's a push button, I will say PB first before giving a name. It's just my style, okay? So we need to get the value, okay? We need to get the value of those two, okay? So for the type, let me call it T, okay? We'll say type, we'll call it T. We'll get the value of the type. Get pop type, get pop type value, right? Get pop type value. And then for the other one, was that nature, I'll say n, get pop nature, value. All right, so we have that. Now I'll say if t, is it t? Yeah, if t is equal to 1, so t there is a type, so let's just say switch, okay? Let's use a switch t, okay? In the case where it is 1, then we are in a distributed load, and in the case where it is 2, then we are in the point load. Okay, good. All right, so switch t, in the case where it is 1, we are there. In the case where it is 2, we are here. Okay, so for the case where it is 1, so all of this is supposed to be point load data. Okay, but then the point load data there is not sufficient, right? Because we have written p here the way it is, which is not normal. We are supposed to multiply the value of p here by 1.4 if it is a dead load. So why don't you use find when you are looking for something? Brenda, please, your question formulated well. Looking for something like what? Because I was not looking for something per se. So, what was I saying? So the point load value here, will not be exactly what the user enters. Okay, we need to multiply it by a safety factor depending on whether we are in a live load case or in a dead load case. Okay, so for the case of P in particular, right, we need to do another. We need to reswitch. Okay, we need to reswitch. Must we reswitch? Yeah, we need to reswitch. And this time around, what we are switching is n, okay? And we have a case where it is 1, we have a case where it is 2, and we'll end there. Now, for the case of n, let's go back to that interface. Okay, this is it here. When it is 1, it is a dead load. When it is 2, it's a live load. So, what we have here is we'll get the value of p set will get the value of p, all right? But then the value of p that we get if it is a dead load, we need to multiply it by 1.4, all right? And then we'll also get the value of p set when it's a live load, but if it's a live load, we need to multiply it by what? By 1.6, all right? We'll apply the same logic. It will be basically the same logic because this switch case here, all of this is for the case of a point load, right? When we reach, let me write it here. Point load. I want us to finish with point load first and be sure that even when we are adding, okay, it is playing. The other thing we need is a variable in the background. So where we are working, because when we are adding these loads like that, it's not enough to add them graphically and see that the loads are appearing on the beam where we want the loads to appear. It's not enough. It's not enough at all. The loads need to appear on the beam where we want it to appear, sir. But we also need to have a trace, a variable that has kept all of those loads intact in our background. Okay, so for that, I'll create a variable. Where is it? I'll just call it data. Okay, data. I'll create a variable. I'll call it loads. Okay, and that load will be an empty cell. What we will do is very simple. Okay, within the cell, we will say that the first position in the cell, the first position will be the nature of the load that we have added. All right. The next position will be the type of the load that we have added. Okay, and then the this thing, the the other position here will be the magnitude of the load that we have added. And then here will be the position. So we'll have these four columns. We'll have these four columns. So a way of saying, if I add a particular point load, for example, what I mean is that there is a find option in MATLAB. The shortcut is Control F. So instead of scrolling to the search for control, you just type find. Yes, Brenda, I know that. I know that, but there is no need for me to actually use it here now. Okay. Ideally, what I can even do is actually to split my screen into two. Okay, to split my screen into two and then search for the code this other way and copy it and put it here. But it's okay for now. The code is not too complex for me to be using all of those techniques right now. So it's okay. Let's just go with what we have now. Okay. Good. So what we will do is that each time we add a particular load, okay, we want to add it to this load variable that we just created. To have a trace of the load, okay, as a variable in the background in such a way that when we click on calculate, we are now able to have a variable behind that has all those loadings and we can calculate. Okay, so the nature here obviously will be live or dead, okay, and then the type here will be that or that, and then magnitude and position. Magnitude in the case of the point load will just be p. In the case of distributed load will be cure1, cure2, and then position in the case of a point load will be a. In the case of distributed load will be a and b, right? So that when we now click on calculate, we are able to take this variable, okay, this particular variable here, and this is what we will process. This is what we will take and go and process together with the functions that we created first to get the internal distribution of each of the loads. Okay, then we can now. I'm making it as if it's too simple. When we reach there, it will be another challenge, guys, to have the accurate value at all times. It will be another challenge. So, but we are not there yet, and we thank God for that. So, what we want to do, what is that? Good. So, once we have added a particular load, we have taken the A value, we have taken the P value, and all the like. The next thing we want to do is to store it in load. Okay, so we'll say load of n plus 1, right? Load of n plus 1 to say the last value plus 1 at the level of the row, comma, the whole column, all right, should be equal to, let's now put what we want. What is the nature? Okay, what is the nature that we want here? Hey, we need to enter it according to the nature here. Okay, we cannot just enter it like that. So it will be immediately under the P here. All right. So here, for example, for the nature, we know that the nature is what is 1. All right, comma. We know that here the case is 2. Are we together? For the type, the type is the second 2, and then the type. The magnitude is what is p. That's what we calculated just now. Is p, and then the geometry position here will be a. As simple as that. So we have the same thing this way. We have the same thing this way. 1, 2, okay, and then here would be p, comma, but here is not 1, right? It is 2 to say dead load. Do we even need the nature again per se? Do we really need it? Let's just put it just for the sake of traceability, okay? Let's just put it for the case of us being able also to retrieve the original load if we need it. Let's just put it. Okay. So backup and here checkup. Okay. So we'll have something, we'll have a function very similar when it comes to the case of distributed. All right, distributed. Just that in that particular case, okay, we can copy all of these, but except this point load draw because we don't have a draw function for that one. Yeah. And put it in case one. Case one here will be for distributed loads. I hope you remember that. So let me put it there. But now in case one, what changes? What changes is that we also have a B. Okay. We have a B. It takes B, right? At the level of the loads here, it is Q1 that will be equals to A text of P here, okay? And then the other one we can call it A text of P2. We'll go and name it. We'll go and name it up there right now. And it will give us Q2, right? A text P2. So for us not to get too confused, let me split the screen the way I intended to. Okay, so we have the original this way. Let me just go up. So this is B, right? It is A text B, good. A text A, A text P for Q1. So we want A text P2 for Q2, right? P2 for Q2. And then we want to make sure that there's no longer any A text B whatsoever. Good. Good. So we are here. We're here. So we'll Q1 multiplied by 1.4. Here we'll multiply by 1.4. It's the same thing again that will happen. Or let's just finish with this one. Then we'll copy it and paste it here and change the corresponding values, right? So now, to add this particular loading, what will it be? It will be 1, okay, comma, 2, agreed, agreed. No, not agreed. What am I saying? 1, comma, the type here is 1, right? It's not 2. It's a distributed load, all right? The type, the distributed load, as we see here. As we see here, sorry, here, the distributed load. And then the value now here will be a vector, okay, that will contain Q1, comma, Q2. And then the value here, we'll put it a vector also, that will contain A, comma, B. Now, I want to mention something while I'm doing this. Okay, yes, I want to mention something while I'm doing this. What I'm doing is not Cramer's rule. Okay, it's not Cramer's rule. It is me that is doing it. You do it differently. All right. You could program it differently. You could program it your own way. So it is not the solution. It is just a solution. You can do it maybe even better than me. Okay. So this is just my way of doing it. You should keep that in mind. All right. That being said, let's continue. So the load now will be added here. Now will be 1 as we said, and Q1. Perfect. Perfect. So I can copy this and then paste it here. So what changes now is 1.6, 1.6, and then the nature here is 2, not 1, right? 2, not 1. So that's that. Okay. So this is the way we'll collect. Each time we click on add, it should add it to the load variable so that we have a trace of all of our loads. All right. Good. Because listen, we have to be able to add a load. We have to be able to edit a particular load that we have added. So if we have added a load, for example, to be 10, okay, and we see that that 10 like that, we want it to be 15 instead. We have to be able to click on that load and make it 15. All right, and if we have added a load 10 by mistake and we don't want that load again, we have to be able to click on that load and delete the load. So if we delete it, it should delete all the data. If we edit it, it should edit everywhere. If we there is a lot of there's a lot of bookable. Eh? Wow. Okay, so let's continue. Let's continue. Are we going to be able to edit? Maybe editing for us will be deleting and entering a different load there. Yeah, just for the sake of saving time. It's already a whole software that I want to develop here. Okay, so we were here, right? We were this way. So for the sake of tracing this load variable, this load here, I want to try and make it a global variable. All right. So let me just say global load so that I can have access to that variable in the I can have access to the variable in the window. So I want to trace the way that load will be behaving while I am adding. So let's go again. So point load 5 2. Alright. So there's an error. That's good. Let's begin to see what's happening. Conversion to double. Conversion to double from cell is not possible. Who is doubling the conversion to cell? Okay, let me try something different. If I do it like this, is that okay by you guys? Let me see. Oh la la, what's the problem? MATLAB? Expected one output, keep bracing. Where? From a curly brace or dot index expression, but they were 0. Oh, woo! What do I do with this? Hmm. Okay, look at this. No, 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 no. No, there's no error. There's no error like what I would expect. Hmm. Ah, yeah, yeah. What's the error here? If I say load of n plus 1, can I just be adding them? Can I just be adding them as I can do that, right? I can be adding them as vectors, right? Okay. I can be adding them as vectors. Cell that has other cells as vectors. So let me try that. Let me look at something. If I do it like that, what happens? Okay, perfect. Perfect, okay. Added it, perfect. It has added it, so we have our cell there. That's good. That's good. So we need to do the same thing everywhere. Let me add here -5 and 0.5, for example. Good. So it's just adding, right? If I do load again, it has added. It is now two values, right? It is now this one and this one. So load of 1 should give me these values. 1, 2. You see here is 7. 7, which is 1.4 times 5, right? And then this is the position 2. Okay. And then the second load will be, let me put 2 here. The second load will be -7, okay, and then 0.5. Okay, perfect. Perfect. But there's something I want to try out, okay, because uh, should I say I'm not very satisfied? So if I put brackets here, it's not supposed to be brackets. So that I have access to the cells immediately. If I put bracket here, what does that give me? Okay, for that, I need to set the load here back to an empty cell. Load is equal to empty cell, right? Yeah. So let's add. It has added, and let me add again elsewhere. 1 is not adding. Error. What's the error? Evaluating unable to perform assigned indices. But did it add the first one? Okay, so we'll just keep it the way. Let's keep what works, right? So Control Z, Control Z, Control Z, Control Z, and then here up. We should not forget at the level of distribution. This is what should happen, and here this is what should happen. Okay, great. So now we can collect all our loads. Okay, it's not a problem. We are getting the values. The problem here is to represent the values in an acceptable format, in an acceptable manner. How do we do that? Okay, how do we do that? So, uh, uh, mm, uh, in the next session, aye. Okay, no, let's just finish the point load here now, right? Let's finish the point load and maybe even start the distributed load. Okay. So for the point load, what we need, let me show you guys a dilemma. You see, let me close this. We have to remove that other one as global. Okay, we no longer want it to be global. It's okay. It's working. So guys, this is what we want. Listen. On a level of points, we put 5 here and then put 2 here. There's an error again. What's happening? Undefined function load or variable load. But there's load here now. Do we not initialize load to something? Or loads. Okay. Sorry. Okay, it's supposed to be loads. No, let's change it to load. It's easier. Alright. Let's change it to load. We could also use a find function that Brenda says, but it's okay. Let's just change it to load. It's not a problem. Okay. So I want to show you guys the problem here. Good. So we have 5, for example. If I add 15, okay, I'm going to put it at position 1. What is supposed to happen? You see that the 15 here has the same magnitude as the 5 here, which should not be the case. Okay, what is supposed to happen is that we should clearly see the difference between those two magnitudes. It means that 15 should be the highest, and then 5 should be relatively small compared to 15. So what we want to do is that we want to set a scale of 0 to 1. No, we have seen that 1 also is very high, right? 1 is too much. So let's just experiment even with those values and see. We are at the level of point load draw. Okay, so let's experiment with those values. Let's try 0.5, for example, or the length also. Can it be fixed? Five. So 0.5. Is that height okay? I think the height is still too much. It's still too much. We don't need a very large height. Okay, 0.25. Let's see. Yeah, something like that. But then the arrow also have to be the arrow also have to be small, right? Not what we are having there. Yeah, something like that. Yeah, good. Good, something like that. So we can take that reference to be our maximum. Okay. All right. So we'll say that all our loads will have to vary from zero in a scale of 0 to 0.25. All right. And their openings will go from, no, not even from zero. That one, where is that one? 0.05. We'll see what to do about that. Okay. We'll see what to do about the opening of the arrow. Okay. I've already opened too many applications here. Okay, so the question now is, how do we do that? How do we do that? So, uh, we could store a maximum value of p each time we have a new variable. Okay, we will store a maximum value of p, but then if that maximum value of p is exceeded, then there can be some technical issues. Ha. That there will need to be a whole looping process that revises all of the point loads that we have drawn before all the time to be sure that we are always on touch. How do we do that? How do we do how do we do that? Okay. So we'll have a maximum. Let's on data. I'll just enter p. I will say p max. Okay, the maximum value for p. We'll initialize it to 0 just for it to be a global variable. All right, just for it to be a global variable. Now, when we enter this function, where is it? When we enter this function, we have two case scenarios. We'll have the case where the new p that is coming, okay, we want to know if absolute, because we don't care whether it's we want to a positive value, okay, it should not be negative here. We want to know if the absolute of p is what greater than p max. If it's greater than p max, then something should happen. Else means it is less than, should we say greater than or equals to p max? In fact, else means that it is less than or equal to p max. Right, let me say else if o, because else must not mean that, right? Or else must mean that. Yes, else must mean that actually. So let me just say else. Let me just say else. Now, if apps of p, the absolute value of p is greater than m max, is greater than p max, then we have a problem. We'll need to redraw this new p, but then we'll have to redraw all that was existing before it to put it to the scale of the new maximum. But if it is less than p max, then we can simply draw it to scale according to the p max, because p max will give us the scale. Okay, so the way we are saying that it varies from 0 to 2.5 when we are drawing, we are actually saying that it will vary from 0 to p max, the real value that the user has indicated. So this will be our interpolation. All right, 0 corresponds to 0, so we have 0, we have p max. Here will be the real values. Now, this way we need the drawn values. Okay, what we'll see on our graph. Okay, and the drawn value 0 will correspond to 0 still, but p max will have to correspond to 0.25. Okay, so what we are looking for is what is the drawn value of any other p that we want here. We'll call it x. This is what we are looking for, this x like that. All right. So for any other p, what is this x? Okay. Wow. Okay, sorry about that. It was connection that gave up on me. It's connection that somehow gave up on me. So I don't even know when it did that. Okay, so here you guys are getting me now, right? Everybody is getting me loud and clear, right? Please just confirm to me that you're getting me so that I can continue. Okay, I'm sure you answer. I'm sure it's because everything here is showing me that all is moving on just fine. So it means you should be getting me. So mhm, okay. Let me just be sure because all right. Okay, so okay, good, Sheila. Thank you. Thank you for the answer. Okay, thank you, Brenda. Okay, so I was saying I will create interpol in order to have this value. Okay, so what we need is a value x out of it. All right, is the value x out of it. But for the sake of not stressing, should we say it's okay? It's okay. Let's just go. So here, if we have to look for x, what is it? We have two sides, right? We identify the maximum on one. We choose one side, identify the maximum, and then play the game, right? So here I will have p max minus p divided by p max will be equal to 0.25, the corresponding value, 0.25 minus x divided by 0.25. I need to pull the value of x, right? So this implies that x will be equal to 0.25, 0.25 minus uh, 0.25. In fact, 0.25 into, I don't know why I'm writing all of that, 0.25 into 1 minus p max minus p all on p max. So that should be correct. Yeah, because this one multiplies this, and then this comes this way, this goes that way. Yeah, that should be correct. All right, good. So I just need to enter that formula. Okay, so what we're saying is here for interpolate x will be equal to 0.25 times 1 minus p max, okay, minus p, all that divided by p max. So this and that have to be divided by p max. Okay, so that'll be my x. What does this mean? This means that with that particular interpol function, I can get the correct value to plot. I can always get the correct value to plot. And then if we put a correlation between these two, look at, if I put a correlation between this 0.25 and this 0.05, what's the correlation? 0.25 divided by 5, does it give me 0.05? No, 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 no. I don't think 0.25 divided by 5. I don't think so. Okay, it gives me 0. What am I saying? I don't think so. Ha. It gives me 0.05, right? Good. So it means that that's the correlation between these two. Okay, so the L here will be that length. Okay, so what I'm trying to say here is that instead of using now, uh, uh what am I trying to say? What am I trying to say? Here let us say abs of p. Okay, so that p here is always in absolute value. All right, let us say abs of p so that I can use interpol and just put p there all the time. So the new L here with no stress will always be equal to interpol of p, okay, times the sine of p. That's what will happen. That will be my new L all the time. And then I want now my A here to be always L divided by 5. Okay? Something like that. Something like that. So let's see. Interpol of P times sine of P. Hmm. So what I want us to do now actually, okay, no, we're not finished. We're not finished. Let's not get carried away. So now if abs of P is greater than P max, okay, we have a dilemma here. We'll need to say P max, okay, should be equal to that particular abs of P, right? Because if P is greater than P max, then it is that new P that was indicated that is a new P max, okay? And it is with that new P max that we need to redraw. In fact, we need to redraw. We need to redraw every load so that it comes down to the scale of the P max. I think the redrawing part we'll do it from next time. Okay. For now, let's just make sure that if we have a particular high load, all the other loads that are less than that load will also follow that pattern. So let me remove this else part. We'll continue in this else part, or let me leave it, but we'll continue from there. We'll continue from there next time. Okay. Uh, what's that? What am I looking for? Applying. Okay, let's apply and see. So let's have a maximum value. Let's enter something like 20 kilonewton at a distance of 0.5. Good. So it should give us that value. Are you seeing that 20? It gives us a particular value. Now let's add 15 kilonewton and let's make it negative. Negative 15 kilonewton, and let's put it at a distance of 1. Okay. So I will have set instead positive so that we can actually measure them, right? You can measure them. So are you seeing how 15 is? 15 is not like 20. 15 is less. So we can clearly see the difference between these two loads. If I put 10 now, okay, and put it at a distance of, let me say 1.25. Are you seeing how 10 is? 10 is smaller than 15, okay, and smaller than 20. Okay, so that's what we're talking about. If I put 5 at a distance of 1.5, 5 again is smaller. So that's what we're talking about when we say the scale, okay? The scale has to vary. But now if I come and put something like 25 and I add, you see that 25 comes again and it wants to be like the 20 that was there. Are you seeing that? So it's not okay. It's not okay. 30. Let me put it at 2. And I add. You see that it's the same thing again, right? So normally when we put 30, what's supposed to happen? What's supposed to happen is that, yes, that's what I'm doing, Brenda. So 30, what's supposed to happen is that it's supposed to give us this value, yes, right, to this scale, but then all the other ones like 20 and 15 have to reduce. Okay, so we need to go back to all the loads that we had drawn and then redraw them. Can we not do that very easily, by the way? Can we not do that very easily? We can do that very easily and very fast, right? because yes, we can do that very easily and very fast, right? So here, papa, else we will do something, but then it will always be the same process here. We have no problem. But then here, here. If it is greater than, how can we process? Normally, you remember that we had this graph right here, right? The load. Let me go there again. Have we deleted those values? Yes, we have. Yes, we have. But it's okay, right? You remember that load function? It contains all of our loads, right? And we have all of the magnitudes that are stored here. You remember at the level of the third position, all the magnitudes are stored there. Okay. So if we come and we say, hmm, let me first of all just display something. Let me say load of 1. And then the magnitude there, what's the magnitude there? Guys, we are almost done. We are almost done. So a little bit of patience, please. Okay, so this is the way it stores it. In load of 1, there is a 1/4 cell. Okay, and it is within that cell that we can index again. 1/4, 1/4, 1/4. So this of that will give me something. Okay, good. And then load of 2, there's another 1/4 cell. Okay, so that's the way it stores it. So this load variable will actually give us the number of loads that we have already indicated. This load variable here. Okay, it will give us the number of load that we have already indicated. So what we can do is that we can, once we have ascribed a new P max, okay, we can go back and then somehow redraw those loads very, very easily. But we'll have to use a function in the function. So we'll use point load draw in the function. And to do that, we will need to have somehow stored all of our previous loads. So look at this. I'll give all of our loads a particular tag value, okay? I'll give it a tag value and we'll call it, let's say, we'll call it loads. Let's say point, okay, let's say point, to say point loads, okay? We'll call it point. And then here, the moment P, what we are indicating as P has exceeded what we took as P max, okay, it implies that we have a different, sorry, okay. The moment it has, thank you, Rita, the moment it has exceeded, it implies that we have a new P max, therefore we have a new reference. All the loads that existed have to be redrawn according to that reference. So what we need to do is first of all delete the loads that existed. So for that, I'll use the delete command. That helps me to delete objects that have been drawn. But then I'll not have to, I don't want to delete everything. I want to delete just those loads. So how do I get those loads? I'll use the find object function, okay, and then get the loads that have all the ones that have tag, all the objects that have tag point. Okay, I hope that we did not use point. Or did we use point? No, it was distribute, right? But let me say point J here to say point graphics. Okay, point J, something like that. So I will delete all of the objects that have point J, but I'm deleting them because I want to redraw them. Now, how do I redraw them? Okay, how do I redraw them? I can use the function in the function. Okay, so what I'll do here is that I'll have to browse through all the existing loads. So I will say for I equals to 1 right up to the length of load. Okay, and for I equals to 1 right up to the length of load. We want to go load by load. Okay. Now we'll say if, because there is a load type here now. You're seeing it here. We'll first of all ascribe the particular load. We'll say um, load is equal to be careful, be careful. Uh, LD. Let me just say LD here. I'm looking for to say load definition is equals to load of I. Okay, so from here now I can index here. Okay. So remember here, this is what indicates. Okay, you're not even seeing me. Here, this is what indicates the magnitude of the load. But here we have also the type, right, that we need. When it is type 1, it is distributed. When it is type 2, it is what? It is point load, right? So here we want to say that if LD of 2, right? Of 2, this is the second information there. If that information is equal to 2, then we are in a point load case, right? And now that we are sure that we are in a point load case, what do we want to do? We want to draw that load. So we'll just say point load of P. What is the P here now is the question. The P here will be LD of the magnitude that we have stored, right? The magnitude here, which is 3, is at position 3, sorry, position 3. And then the point here, what will be the value? It will be 0, comma, the value of A, which is what? LD, comma, LD of position, right, which is 4. Okay. So this is what we want. If abs of it will come back. Okay. Now here, else, what we want is this. This is the else that we want. Okay. And then for both cases, it's supposed to do this. It's supposed to draw. Aye, aye, aye. Something tells me that there will be a ping somewhere, but anyway, let's just try. Okay, let's try and see. Okay, so let's give ourselves 20 as the first magnitude. Even if it's as no problem. There's already a ping. Okay, let's see that. Undefined function A, that's a minute ping. Where is it? Oh, okay. Okay, so actually this if does not even need an else. Okay, we just say end, full stop. It doesn't need an else. Okay, so that we can have these guys here that will play in our favor. Yeah, perfect. Perfect. Okay, it doesn't need an else. So let's go again. Now, I'll close you so that we can start again. Point load 20 here, 0. Yeah, it's okay. Let me put negative 20. Let's deal with the nodes. Yeah, like that. So we said when it's 15, okay, if I put negative 15 and I say 0 0.5 or 0.25, good, right? It's small. The problem is when it's larger than the 20, what should happen? Let's say 30. I will put it at 0.5. Wow. Okay. So what has happened? And why is it doing that? It has not deleted the loads that we expect it to delete. And it has withdrawn some loads that we don't want. Hmm. So this is the worst kind of error, guys. Mhm. The worst kind is that there's no error, but you have a kind of result that you did not really expect. So let's begin to figure out what happens here. So normally when it's drawing this, it's giving it the tag of that. So it's supposed to delete find object tag, da, 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 da. No problem, it has to delete it. But what is the problem here? For I1 length of load, so go load by load, and then oh la la. Hmm. What can we do here? 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 What's the problem? When we look at these graphics, what can be the problem? Because here the load is still there, the load is still there. It has represented this one, it has represented the, have I, oh my god, look at that, come on. I'm confused, right? This LD is supposed to be on the X side, not on the Y side, right? So it's supposed to be this comma 0. Okay, yes, it's supposed to be that comma 0. There's no comma here. So let's all about try this because it's supposed to be LD comma 0. Let's all about try this and then we'll see the rest. Yeah, it's A comma 0. Okay. Okay. So let's remove the paper again. Okay. So first load, point load. We said negative 20 at 0.25 add. Okay. The next one 15 at 0.5 add. Okay, so let's go now to the 30 at 1 add. Perfect. Okay, exactly what we need. So you see that the 30 has come, it has taken the maximum value because 30 now is the greater value. Okay, and the 20 has shortened down and the 15 has shortened down. So you can clearly see that this is the highest force here. This is the next highest. This is the next highest. That's what we need. Okay, so if I say 50 again, for example, and I put it at the level of, let me say 2, right? You see 50 is taken and then the others have shortened. Perfect. Perfect. So I think with this we can say that we have finished the implementation of at least the modeling of the point loads, right? We have not yet seen how to click and delete. We'll look at that. But then next session we'll implement the uniformly distributed loads. We'll delete the loads and all the like, and we'll make sure that the values of the loads are valid. Okay, and then make sure the values of the loads are valid. Yes, and then from there, when we are able to collect real values and we are able to see that our element, because there will be a next problem when we change the length here. So for example, this is 3 meters. It's good. Everything here is good. If I change the length, for example, to 2 meters, okay, there is a problem. Look at that. It disappears, right? So normally, the loads are supposed to realign themselves. So in fact, it's a whole ball game, okay, that we'll be looking at progressively. So we hope that we will be done. We'll be done with this. Hopefully next time. Hopefully next time. So see you guys in the next session. So I want to see all of you guys on Zoom for just 10 minutes. Okay, just 10 minutes, 20 minutes, just to know those who were there, those who were not there. All right. Okay. So see you guys and bye bye. Tell me bye bye, please. Just type bye bye so that I can end the conversation. Hey guys, tell me bye bye. Tell me bye bye. So you have to do the same exercise. Do the same exercise with cantilevered beam. Cantilever. Don't forget cantilevered beam. Do the exact same exercise with cantilevered beam, and let's be discussing on slab. Okay. So see you guys in 5 minutes. Let me just set up the Zoom meeting. In 5 minutes, we are meeting. Okay. 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 Bye bye, guys. Bye bye.